change, inshallah. Yeah. So just wait. Maybe it will be announced in the beginning of semester 1, 2021, inshallah. Yeah. Okay, but currently I am the Deputy Dean for Student Development and Community Engagement. These are my staff. Okay, now the programs that you need to choose, brothers and sisters. There are 8 programs that you are going to choose if you choose engineering. Okay, but before that, what is the difference between engineering and KICT? Yeah, no wonder, yeah, I believe that you can take engineering and KICT, but maybe, yeah, maybe if you put it in this perspective. At Kulliyyah of Engineering, we have this Board of Engineer and also accreditation by Board of Engineer, and our programs are all recognized by Board of Engineer Malaysia, not only Malaysia but also worldwide. Yeah, so our graduates, there are laku, yeah, they can work everywhere in the world. No need to take extra special certificate, for example, in order for them to work in Australia, yeah, in France, in United Arab Emirates or other places. Yeah, so our programs are well recognized, and a degree in engineering, I know that it is quite difficult. Yeah, do you agree, Iman, Rauda? Yeah, Arif? No doubt engineering is difficult, but if you are very interested in it and if you put all your effort there, inshallah, it will worth it. Yeah, it will worth it because throughout the years, you will be trained for problem solving and critical thinking, and um, and this problem solving and critical thinking is not only useful when you will become an engineer, but also useful when you are um, in your daily life. Yeah, for example, you have, yeah, routine. Yeah, we have problems, financial, family problems, and so on. And through engineering, because you always train to solve problem, inshallah, you can manage. So we have 8 programs, and for your batch that will come to Gombak campus in September, I believe, this year. Okay, 8 programs are: first, chemical engineering with honors. This is new program just offered previous semester, semester 2, 2020, 2021. So that small batch of students, they undergo all this new curriculum. So these new curriculum are very fresh. So you are lucky, yeah, brothers and sisters. It is very well updated to the current demand from your employer out there. But we encourage our students to be the job creator as well, yeah. Okay, so we have chemical engineering. We have electronics and electrical engineering. If before this, the program of electrical and computer engineering offered 2 programs that are communication engineering and electronics CIE, computer and information engineering. But right now they go back to the basic, yeah, electronics and electrical engineering. And next we have manufacturing engineering, materials, aerospace, mechanical automotive, mechatronics, and civil engineering. Civil engineering is quite new, but it is I think 5 years already established, and our graduates are most accepted in the industry, alhamdulillah. So bear in mind, yeah, brothers and sisters, stay throughout the program that you will be briefed by our academic advisors from all of this program. Okay, maybe this one is important as well. To enter Kulliyyah of Engineering, the CGPA for CFS student is not high, yeah, brothers and sisters. It is achievable. It is achievable, which is 2.5. And other requirements such as Bahasa Melayu and also Pendidikan Islam, you already obtained that because you already took SPM. And I know that many of you did very great in SPM, yeah, and I hope that you will continue at CFS and also at Gombak campus later on. Okay, so these are our academic advisors. For first year students, without measuring, that's mean direct intake students. So this is not applicable to you. The academic advisor will be me, myself, but the other students with measuring, once you enter Gombak campus, you will be given majors. So these are our academic advisors. And academic advisors, they are very helpful. They can help you in your study plan and other problems, inshallah. They are not a problem solver, but then inshallah they will channel you to the right person. And at Kulliyyah of Engineering as well, brothers and sisters, we have this mentor-mentee system where all students are assigned to their mentor, and the academic advisor will lead all the mentors at your department. Okay, so here are the head of departments. Later you will meet them. Okay, this is quite important as well. Brothers and sisters, today our program is organized by ANC, which is one of the student society at Kulliyyah of Engineering under Enginius. At KOE, we have engineers, we have associations and club under engineers, we have IIUM robot team, we have student union for Kulliyyah representative, and many others, yeah, brothers and sisters. And I really hope that you will join, the student society, so that you will gain the extra curriculum activities, you will gain more skills, you will learn how to manage, you will learn, or you will enhance your leadership skills, and you can engage with your friends. I know that nowadays all of our programs need to be conducted online, but we don't have so much choices, brothers and sisters. So whatever we have, we must adapt. And I hope that you adapt very well during this new norm. And engineers, I just want to send appreciation from our dean during last Friday Kulliyyah board meeting, where he said that regardless the conditions, engineers are always very active. Like in the previous month, 11 programs, 11 program by engineers were conducted through online. There are TED talk. The TED talk is not from the outside people. You yourself, the students themselves, they talk about vaccine, they talk about the past, present and future engineers, the topic like that. And there are also e-sport. What else? We organize this iftar and many others. So don't limit yourself that you cannot do this, you cannot do this because you cannot meet your friends. But the world is beyond that. So you must use whatever facilities that you have and take it positively for your advantage and also for the ummah. Okay, so this one I will go quickly. Not much time left, brothers and sisters. We have international and local students, and I hope that you can mingle around. You can get to know our international students, because from international students we can learn their new culture. We can communicate very well. You can practice your English, because IIUM engineering graduates, we are very well known about our capability to converse in English, and you should try that, brothers and sisters. I myself, when I was young, my English is not so good, but then um, the pressure, comes from our external factors, so we must practice, okay. And what else? Distribution of students. Okay, more or less about the same, brothers and sisters. The Kulliyyah will try to moderate, all the measuring about the students distribution. Okay, let's say if you target to enter civil engineering, and usually civil engineering for one semester, they will take like 50 students, and let's say 100 students applied for civil engineering, you just guess how the Kulliyyah will choose. Of course, it will be the best, top of the cream, right? So brothers and sisters, right now, what you need to do is to do the best in your final exam, and then score the best as you can, because if you have the highest CGPA, if you have the right skills and attitude, inshallah you will be chosen to your first choice will be accepted by the Kulliyyah. So my advice is just do the best at whatever you do, and let the rest we just leave to Allah Subhanahu wa Ta'ala, because Allah knows the best. Allah is the best planner. Okay, this one is quite important as well, brothers and sisters, about the distribution of students' CGPA. And recently, not very recent, maybe last 2 months, yeah, Brother Fakih and also ANC helped me to do this survey. Yeah, why first year students' CGPA are comparably low compared to other level of students. Okay, and at first, we thought that maybe the students have cultural shock from CFS to the Kulliyyah. And the answer from the survey that we obtained, yeah, Brother Fakir, if I'm not mistaken, we received more than 80 respondents from first year until fourth year. So the students said that, yes, they have problem. They have received CGPA lower than their CFS, and the reasons are due to at CFS, it is more like a sekolah menengah, like your boarding school, like your uh, secondary school, where the teachers, they do tutorials together with the students. They teach the students maybe one-to-one, I'm not very sure. And it is more like school kind of relationship. However, at the university, you feel very shocked where the classes are very huge, yeah, and the lecturer just talk, give the lecture, give the video, give the slide, and then you are asked to listen to the video, and in the next class you are asked to answer the question or to discuss or to do the assignment. So the students feel very shocked, and they couldn't do well in the first year. But I hope, brothers and sisters, since you have this insider info, yeah, so I hope that you can prepare your mind that when you enter kuliah, so no more sekolah menengah, yeah, no more teacher. They are your lecturer, and you need to be more independent, and you need to learn, yeah. The term is you need to learn. You don't wait the teacher, the lecturer to spoon feed you. You need to learn, you need to explore, you need to discuss. So I hope this batch of students who will enter kuliah of engineering in semester 1, okay, your CGPA, I hope that first year students, you will be at the 3.5 and above here, yeah? Okay, if that is too much, maybe we target at 3.0 and above. Okay, next. Okay, staff at KUI, insyaAllah you have a very good number of lecturers, professors, associate professors, and technical and admin staff. And last but not least, brothers and sisters, for detailed information, you can always refer to our Kulliyyah of Engineering website. And we have also a Kulliyyah of Engineering undergraduate information. Please follow our Enginius IG, yeah, Kulliyyah of Engineering Instagram, and also Kulliyyah of Engineering Twitter. So you must be engaged with us, brothers and sisters, in order to know more. And for any further inquiries, please email me at hasmahm@iium.edu.my. So I wish you all the best, brothers and sisters. I really hope that we can meet in the next semester virtually or face to face, inshallah. Just pray to Allah that the situation will be getting better, that we can have face to face class, face to face activities. Yeah, please pray for Malaysia, please pray for Palestine and all Muslims in the world. May Allah protect us. Thank you very much. Assalamualaikum.
Waalaikumsalam. Thank you, Dr. Hasma Mansur, for the wonderful remarks. And it's very informative regarding she touched on the entry requirement, AA, HOD, program structure, and many more. We shall proceed to our awaiting program. I'd like to invite Dr. Ahmad Jazlan Haja Mohidin, the AA representative of Mechatronic Engineering, to give a brief introduction of the major. Please welcome.
Thank you. Thank you very much to Academic Anchor Bureau. I'll just share my slides. Okay, is it clear? All right. So thank you very much to Dr. Asma Mansur for the introductory speech about our kuliah, and also thank you very much to Academic and Career Bureau of Engineers. So I think one by one, each of us, we are going to introduce about our departments, what we have to offer. And I think that the information we give will help to guide you in your decision making, whether you want to join ICT, whether you want to choose a specific major in Kulliyyah of Engineering. So I will be explaining specifically about mechatronics, and I hope my explanation gives an insight into what option that you have if you decide to choose mechatronics. So I was looking at some of the questions that I received from you, from the students. So Academic and Career Bureau, they compile some questions. So I tried to make my presentation to address those questions that I received. So what exactly, one of the common questions I got is, what exactly is mechatronics? What will you learn and what will you work as in the future? So mechatronics, when we say mechatronics, the terminology that comes to our mind is we deal with sensors, we deal with electronics, and nowadays we also deal with cameras as well. Vision is a common, a new, we say technology. We have smaller cameras, cameras with better resolution. So that's vision, we say, is one of the technology behind self-driving cars. If you have heard about Tesla self-driving car. And then in mechatronics, we also learn about things like this is like a single, this is a single board computer. So it's a Jetson Nano development kit. So what it does actually, we call it's a single board computer. So what you have right now, you have your laptop. Your laptop is a computer, but suppose I want to have a computer in a remote location. For example, I want to monitor some engineering pressure reading, for example, water level readings, for example, and I want my system to make some decisions. Okay, when the water level is high, turn on an alarm. So I can do that by using what we call single board computers. So this one is by NVIDIA, if you have heard about NVIDIA. So when we talk about mechatronics, we also deal with actuators. We say motors, pneumatics, hydraulics. So these are the actuators. So we say the sensors which capture information from the environment. We have this kind of like single board computers, also like microcontrollers, which help you do the programming and help you with the decision making. And we also have the actual motors, actuators, which achieve a certain task. Which move a motor, which turn on a motor, which actually open a door, for example. So those are what we call as actuators. And in mechatronics, we also have the element of decision making. We want to incorporate some artificial intelligence. Okay, for example, if you have seen these self-driving cars, okay, your car can estimate the distance between the car you are driving and the car in front of you. So we also have the element of decision making, and we also have nowadays lots of sensors, lots of data is being transmitted to the internet. So our gadgets come with some kind of communication abilities as well. So that element of communication also is being embedded into mechatronics. Okay. So I just give you some examples. This is where one example of mechatronic systems. Back then, in a factory, we would have these, what we call these forklifts. So if I want to move a heavy box, from one part of the factory to another part of the factory, I need to have a driver. I need to have this forklift truck, and from the company perspective, they would need to spend more money to employ this driver for his stocks or his insurance. But nowadays, with all this hype about industrial automation, companies are moving forward or moving towards the direction of these what we call autonomous ground vehicles. So it's completely unmanned. So the robot itself, it can take the box from one region or one coordinate in the factory, and it can travel, it can bring that box to somewhere else, to a desired location. So completely without the intervention of a human. So in the long run, companies, they see this as a cost saving strategy. I don't need to employ human labor. So that's one aspect where mechatronics is being used, how to incorporate unmanned technologies. So this is another example which incorporates a bit of, we say, intelligence. So this is, if you have heard about Top Glove, I think Top Glove has a lot of negative because of this COVID cluster. But in Top Glove, in these glove making companies, they have what we say a quality assurance. So each of these gloves, there is a likelihood of certain defect. One of the defect is, for example, one of the fingers are missing, or there is some kind of hole in the glove. So the quality control, commonly how it is done, thousands of these gloves, you have a human checking one by one. Is it okay? Is it okay? Nowadays, companies, they are looking into how we can automate that process with some kind of like single board computers as well. How can we capture the images of these gloves, and how can we differentiate the good glove that can pass the quality control and the glove that needs to be rejected. So mechatronics can be applied in order to automate, to replace that human element in these kind of applications. Now we also have self-driving cars. If you have heard about ADAS, autonomous driverless assistance system. So what happens in this Tesla self-driving cars, or other companies are also moving into the self-driving cars technologies. We have what we call LiDAR, or light detection and ranging. So I have my car. My car has a kind of laser. So that laser will help me to scan the surrounding environment. It'll help me to scan, okay, is there a car in front of me? Is there a human in front of me? Is there some kind of obstacle? And then that laser will be fed back to you. So you know the the algorithm inside the car, the controller of the car, it can give you a estimate, okay, do I need to press the brakes at this point? Or do I, if the road is clear, okay, the car can move faster. So we are incorporating intelligence into the car. So this is another aspect of how humans are being replaced with the intelligence, with the machine aspect, the machine learning aspect of these autonomous vehicles. So this is another project of one of our students, one of our graduates, where he's working. This is an oil rig, example of an oil rig. So oil rigs itself, they have some areas where they need to inspect, but it's very difficult for a human to go there and check for example, somewhere underneath the oil rig. So we can use drones. Drones can be used such that you can program the drone to fly specifically to where you want to actually see where there's a defect or where there is a damage in the structure. And then the drone can reach hard to reach places, and it can capture images of that part of the oil rig. If not, you would need to have a guy, and he would need to have a harness, and he would need to go down, and then there is that likelihood of accidents. So you can avoid that by using drones. That's also one application or one example of where mechatronics can be applied. Okay, so I won't take a very long time. So one of my advice to all of you is that your major that you choose, it should be something that's exciting to you, something that you are passionate about. Like this is one example of how I think what I learned in mechatronics is it helps me to understand what's going on around me. So if you have seen these very tall buildings, I've always been fascinated. Okay, how do these tall buildings, how are they able to actually withstand like changes? How is it that they can maintain to be stable? So a very tall building, if you have learned from a physics perspective, you can consider it to be like a pendulum. So there is a technology, we call it tune mass dampers. So if you look inside Burj Khalifa or KLCC or these very tall buildings, somewhere at the very top, if you have access to the building, they have one of this kind of structure, this kind of mass. So the principle actually is quite simple, is that you can reduce the fluctuation of a pendulum by attaching another a kind of mass. So by putting this mass at a certain location of the building and having a certain, we say, stiffness, certain dimensions, you can reduce the amount of shaking of the building. So that's one example where mechatronics is being overlapping with civil engineering, with mechanical engineering. Okay, so almost done. So one of the other questions I got from the students is, okay, I graduate with mechatronics, where can I work? Okay, so our alumni, many of them, they are working in semiconductor as well, Texas Instruments, Intel, and then if you have heard of On Semiconductor, all these semiconductor companies, we also have graduates working automotive, Produa, Proton, and then all these food companies, Nestle. So hopefully, when in 4 years' time, when you graduate, the job opportunities will grow. We would have passed this pandemic, and then depending on the economy, there would have been more opportunities. So if you ask me if to help you with your decision making, I would say just look at the synopsis of each courses, see if it's your cup of tea, and then also try asking around your seniors as well. Like maybe don't ask just 1 or 2 people, ask 10 people and see what is their feedback about the program, about their experience. So I think that's all about me. So I'd like to welcome, if there are any questions, just type into the chat box, or if you want to just ask me directly, I'll be more than happy to answer. If not, I think we move along chat. Is there any questions from the floor? Stop share. Right. So I think that's all from me, from my side. That's all for my presentation. I think no questions, right? I'll pass back to our MC then.
Right. Thank you, Dr. Ahmad Jazran, for the excellent introduction. If you have any questions later on, you can contact him personally. Next, I'd like to invite Associate Professor Dr. Rosmi Abdul Rahim, the AA of Electrical and Electronic Engineering, to give a brief overview of the major.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Am I audible? You can hear me, right? Okay, thank you. Thank you so much, Sister Iman. Thank you, Dr. Jazlan, for such an interesting intro warm-up from mechatronics. Okay, Jazlan was my student, Sister Iman was my student, so I feel so old now. Okay. But here I am. I'm going to kind of doing promotion basically for Department of Electrical and Computer Engineering, ECE department. And basically for us at ECE department, kenapa slide saya tak jalan? Okay, so if all this while, if you have ever come across any of these terms, okay, for example, IR 4.0, artificial intelligence, IoT, cloud computing, blockchain or smart sensors, wearable devices, CMOS technology, actually these are all related to us at ECE department. Okay, so I'm sharing with you all these terms to give you the head-ups of what are related to our department ECE. Then from ECE department, actually we are offering one program which is called Bachelor of Electrical and Electronics Engineering with honors with 4 areas of specializations, where we have Computer and Information Engineering, Communications Engineering, Microelectronics Engineering, and Power System Engineering. For the first 2, actually, these are the existing programs, the existing specializations that we have been offering since forever, okay? But for the third one and the fourth one, Microelectronics Engineering and Power System Engineering, actually is a new specialization that we are offering to our students. So you might want to consider this one as well. And although it's quite new to us, but inshallah we'll be having a strong team to conduct this area of specializations. Okay, then why suddenly we are having 4 specializations instead of 2 before this? Actually, we are trying to meet the demands from IR 4.0, from the SDG, then from whatever is happening around us. I mean, we want to be relevant to the industry, to the market. Okay, so that's why we are considering offering these 4 types of specializations. And talking about the first one, which is on CIE, Computer and Information Engineering, is very much related to obviously computer engineering, IR 4.0, and some kind of programming, this kind of things. But you might be wondering how is it differ from ICT, where ICT is doing also the programming, the apps, that kind of things. But in CIE, we are kind of combining both software and hardware. So if you do the programming, maybe later you need to integrate with the hardware, so that you can develop a system, a sensor system and whatsoever using the technology around you. Okay, so this is all about CIE, Computer and Information Engineering. Then if we talk about the job prospects related to CIE, actually there are many that we may consider. Actually it's kind of similar to mechatronics before this, because kita pun adik-beradik kan. So is related to semiconductor industry as well as computers or medical monitoring devices. It can be the consumer appliances, networking, communication, industrial equipment. So whatever systems that are related to coding, programming, and doing the integration of both software and hardware, yes, it's very much related to us. Then obviously, if you talk about the career opportunities, we have alumni now working at Intel, Maxis, Texas Instruments, Cellcom, and many more companies which are doing some kind of business related to this CIE. Then we come to the second specialization, which is on communication engineering. As I mentioned just now, is an existing program, and it's actually focusing on networking and communication transmission system, as well as we study on how to do the data communication, how to send data from transmitter to receiver, this kind of things. Okay, we do the routing and multiplexing of networking. This is not my field, so I just read whatever related on whatever written on the slide. And for communication engineer, basically you'll be obviously dealing very much with the communication system, okay, in terms of doing the research or designing part, or even develop the communication system as part of your job scope. And basically related to career opportunities for communication engineers, actually many job prospects. Okay, it can be under telecommunication engineer, field engineer, or network security engineer. We have many. Okay, then obviously the companies that can be related to under this communication, it can be the telecommunication company like Maxis, Huawei, Cellcom, Digi, TM, and so on. Okay, then for the third one, this is a newly offered area of specialization under our program, which is microelectronics engineering. Obviously, when we talk about micro, we imagine the small size system, small size component, which is at micro level, kan, negative 10 to power of -6. It's very small, okay, but although it's very small, it's very powerful, okay, because without microelectronics, all the big system actually it cannot function. Okay, so I keep saying to my students, be like microelectronics or be like MEMS. Although we are small, but we have the main function of the big system. Okay, so obviously microelectronics in increasing demand because it's very much related to IR 4.0, IoT, these kind of things. And actually you can find microelectronics in everything around you, okay, because when you are using handphone, there will be microelectronics inside that. You are using computer, laptop, or any gadget, actually there should be microelectronics, okay, related to it. Then obviously for the career opportunities, we have alumni working as microelectronics engineer or QC engineer and IC design engineer in many companies such as Silterra, Intel, even Jabil, and as well as Texas Instruments. Okay, then for the fourth one, we have power system engineering. Obviously, it's related to power, and we talk about the transmission and the electricity flow of the system, where it's much related to the, actually I cannot see the slide. Okay, it's very much related to the motors and transformer, and obviously it's also can be related to energy harvester system, which is the one that most people are interested in, because we need to have a good energy harvester system so that we can have a good support system for our technology. And when we talk about power system, obviously it's related very much with power generations, the system analysis, the high voltage, power electronics, and so on. Okay, then if you talk about the career opportunities, yes, there will be, these are the among the job scopes that you might want to consider. It can be related to power system engineers, the line design engineer, the transmission and distribution engineer. Then obviously the related companies are the companies related to power or solar energy or whatsoever, such as Tenaga Nasional, the Green Tech, Sarawak Energy, and so on. Okay. Then I talk about 4 areas of specializations, and we are capable of offering these 4 areas of specializations because we are having a very strong team. So as you can see here, these are the lines of professors, associate professors, and doctors in our department, where we are having 19 male lecturers and 27 ke 28 female lecturers. Okay, so I think I want to mention a few prominent names, such as we have obviously Prof Hadi and Prof Teddy, Prof Zahiro, who are super talented multitasking engineers. Okay, when they are conducting classes, there will be 4 screens at the same time. Okay, I don't know what they are doing, but that's the way they are teaching. And we have Prof Anis, okay, in the picture. Prof Anis actually is the one, actually she's a cancer survivor, so her interest will be on developing a sensor related to detecting cancer and related to health monitoring system. And also we have Prof Aisha and Dr. Rashida, who are both Prof Aisha from Sudan, Dr. Rashida from Nigeria, but I think they are both already half Malaysian, okay, because they stay with us for such a long time. Okay, so this is basically our team, and these are the support staff, okay, that will help you throughout your studies if you join us. ECE at the moment, we have all the academic advisors for our program. We have 2 academic advisors because we are offering kind of 4 area of specialization. So I'm taking charge of 2. Dr. Sharin actually is taking charge of another 2. Then obviously we have all the coordinators at the department, okay, where we are going to facilitate you, to guide you, to assist you, okay, throughout your studies here at the ECE department. Okay, so I'm just sharing because I think I was given 20 minutes. Okay, so I'm thinking of just sharing the photos just to give you the idea how the life in the Gombak campus will be. Okay, if you join us at ECE, then basically our teaching and learning activities are not limited to just slides and PowerPoint and giving notes whatsoever. We have some kind of hands-on activities in the classes. And so if you can see here, we are playing around with the Play-Doh to create the transistor structure for the students to really understand how the transistor works. Then we have hands-on session, okay, where the students do the electronic kits to understand more about electronics. Then obviously we have some kind of projects during IDP final year project, okay, so mostly hands-on, okay. Then obviously apart from the teaching in classes, we already regularly do some kind of industrial visit okay, to selected companies to give the exposure to the students, okay, in many areas. Okay, so for example, in this photo, we managed to visit agency Remote Sensing Malaysia, is under MOSTI. Then this is obviously the MESAT, and we also did some visits to some other companies. Okay, then obviously these are the happening activities in ECE department. Okay, so I believe this is during FYP presentation where we have award session for all final year project students. Okay, then we already also have a visit to Continental and other photos showing you our activities at the department. And I need to mention this, where we have representative students from our department competing here at Innovate Malaysia in year 2018. Okay, they managed to get the first runner up. Okay, this program is organized by Google. And more photos, ECE Family Day, okay, then seminar, presentations. Then actually those that I share with you are obviously before the pandemic, but during the pandemic, obviously our teaching and learning activities are limited to online classes, online platforms, but nevertheless, we try as much as possible to give you guys the best. And for example, even during the pandemic, we managed to do the face-to-face labs for the first year students, okay, because we feel that students also need to have some kind of feeling doing the real circuit construction rather than doing just the simulation. So we managed to do few experiments with the students, okay, obviously with strict SOP that we follow. Okay, then just a little bit. Okay, I think we have few more minutes. Okay, so I'm sharing words from our ECE alumni. Okay, so for example, Sister Elena just graduated, I think last batch, and she's now working as an engineer at Ericsson. So I'm just sharing important points from her point of view, that she said that it's a wholesome learning experience at ECE department, where her head and heart align with Islamic teachings, always can count on supportive ECE lecturers, and she truly enjoyed finding her passion outside and inside engineering studies, okay, by Sister Elena. Then we have Sister Ain Najiha. She's now working at Intel. Okay, so obviously she said that by having all the skills that she learned in at our department, actually is a good point for her to be able to market herself in the industry. Then we have Sister Dayang Komarina, when she mentioned about it's a blessing to have tazkirah in most classes. Okay, that's the beauty of joining IIUM, joining KOE. Although we are engineering students, but the Islamic perspective of it, okay, we don't leave it out. Okay, so she's really grateful for having tazkirah session in most of the classes because it keeps her rooted. Okay, then we have from our brother Irham. Okay, brother Irham was one of our best students, okay, in CIE. Then he really enjoyed, I mean, he mentioned about having great experience at the department. Then he learned lots about programming language and electronics part, which are useful for him after his graduation. Okay, then okay, this is from Hafi. I contacted him last night. Okay, I said, Hafi, can you give me 1 to 2 sentences just sharing your experience at ECE department? Then somehow he gave me an AC because he want to share his stories, okay, with you guys, okay, because he feel that he hope that whatever experience that she's having at the ECE department can help you guys to do your to make your decision. Okay, but I just highlight whatever important points that I highlighted in blue font there. Okay, so he said that he used to be like you guys, having the same dilemma as engineering students, which courses that he want to take as majoring. But his advice will be understand your own interests, okay, because for him, he's eager to know more about future technologies, okay, that will be his passion. So that's why at the end of the day, he took majoring in communication engineering. Then he said that during his studies at EC department, he involved in many design projects, and even he managed to go through a student exchange program in France, okay, during his undergraduate studies. And now, and obviously from the support from, he said this, I didn't say that, from the various talented lecturers, okay. Then he used to work at semiconductor company in Sarawak, but now he's working as instrument and control engineer at Petronas Milling Sendirian Berhad. Okay, so his very last word was, my advice to everyone, pursue your passion and interest. Inshallah, you will always enjoy the process as you go along. Okay, then I would like to add a little bit more. Of course, in order for you to pursue your passion and interest, you need to have a good results so that you can keep the options open. Then from there, you can choose which majoring that really suit your passion, that really suit your interest, that really suit whatever dream that you're having. Okay. Then what are you guys waiting for? Okay, let's join us at ECE department. But at the end of the day, it doesn't matter which majoring you might be choosing later, but I really hope that throughout your studies and being a student of knowledge, always ask Allah for beneficial knowledge. Okay, knowledge that will bring you guys closer to Him, knowledge that will make you a better Muslim, knowledge that will not only benefit you, benefit your family, even benefit the whole Muslim Ummah. Because at the end of the day, we want to succeed in both worlds, right? We want to succeed in the dunya as well as in the hereafter. May Allah bless us among the righteous ones, inshallah. Okay, then always pray and seek refuge in Allah from knowledge without benefit. Okay, because knowledge without benefit actually will cause more harm to you, okay, then may bring you away from Allah. Na'udzubillah min zalik. Okay, so I think that's all from ECE department. I need to give credit to Dr. Sharin as well because we prepared the slides together. And as I mentioned just now, it doesn't matter which majoring that you might be choosing later, but always try to suit your passion, your interest, and inshallah everything will be fine. Okay, so with that, I think that's all. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Rosmi. Before we proceed with the next presenter, I'd like to remind participants to register your attendance with the provided link. Without any delay, please welcome Associate Professor Dr. Mu'min Muhammad Mahmud Idris, the AA of Aerospace Engineering, to give a brief introduction of the major.
Okay, yeah. You can hear me?
Yes.
Okay, you can see my presentation?
Yep.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. I am Dr. Mu'min Idris, the academic advisor for aerospace engineering. Of course, under our Department of Mechanical Engineering, we have two programs. One is aerospace engineering, which I'm going to talk about. And another one is a newly introduced program, which is mechanical engineering. This one, you will hear the details from Dr. Helmi. And before we start our presentation, or before I talk about the details of the aerospace engineering, I want to just to clarify the terms. As you can see here, the word aerospace, aeronautical, aviation engineering, those words are actually you can hear them and there is confusion. What is the difference? And here I will try to explain the difference. First, the aviation industry, it includes everything about, okay, let me use the pointer here. Okay, you can see here the aviation industry. It includes everything related to the design of the aircrafts, okay, and the manufacturing also, and also the operation. Operation means in the airports and in the airline companies. We have different sectors of this aviation industry. We have aviation engineering, we have aeronautical engineering, and also we have aerospace engineering. Of course, we are here in aerospace engineering. The difference, the aviation engineering, this is related to the maintenance, based, meaning after manufacturing of the airplanes and the airplanes already are in service, then the service of those airplanes, it's called aviation engineering. Sometimes they call it aeronautical engineering technology. And the examples here of those programs in UNIKL, MIAT, and UTHM is they have programs for aviation engineering. And also we have aviation management. Aviation management, it's not an engineering, actually it's management. This is for airline companies and airports. And example here again, UNIKL MIAT, they offer this aviation management degree. And aeronautical engineering. Aeronautical engineering, this is relates to anything flying in air. So they don't go to space, and they don't study systems that work in space, like satellites and space vehicles, not in aeronautical engineering. And we have example here like UTM. They have program aeronautical. Now our program here is aerospace engineering. And this is actually, you can call it aeronautical, and another term, it's called astronautical, relates to the space actually. So this is our program here in IIUM and also in other places. You have IIUM and UPM and USM, and this is aerospace engineers. Aerospace engineers can be flight engineer, designer, basically to design the aerospace systems like airplanes, helicopters, spacecrafts, rockets. It's all under satellites. It's all under this aerospace engineering. So this is our program here. What is the aerospace industry? Okay, what is the aerospace industry here? You can see here the blueprint. We have the first National Aerospace Industry Blueprint, 1997. It's related to all aspects of the industry, manufacturing, maintenance, and repair, and overall, this is what we call MRO, and also training and education. And the second National Aerospace Blueprint, this is 2015 until 2030. And also it includes, like previous first National Aerospace Industry for Malaysia, it includes now the design and engineering services. This was introduced, which of course, aerospace engineers, they can work in manufacturing, system integration, training. We don't train you to become a maintenance engineer, but of course, you can change your career later if you want. But aerospace engineering is related to this manufacturing, system integration, and also training and designing here, this designing and engineering service. So according to the second National Aerospace Blueprint, Malaysia is becoming an aerospace hub for original equipment manufacturing for the region with the new Asia Aerospace City development in Subang. And also, as of June 2019, the investment in this sector, aerospace engineering, reaches 15 billion, and with a lot of, I mean, of course, new jobs introduced. And the industry annual revenue is around 12.7 billion. This is all from the website of Malaysian Investment and Development Authority, or MIDO. You can see here the prospect or the future of aerospace industry according to the national plan. Now also, we have up to 159 aerospace industry related companies and institutions. And you can see in this slide the logos of so many companies and also institutions related to aerospace industry, where you can have a place to work after graduation. Now, the aerospace engineering itself, what you are going to study, what is it? Because it's a multidisciplinary field, so it's related to all kind of, engineering. You can see here, of course, is the basics, physical sciences, mathematics. This is basics for all programs. And then you have also something related to computers, programming, mechanical systems, and then fluid structure, electrical and electronic systems, materials, manufacturing. It's all inside this aerospace engineering study. And the aim would be to design air and space vehicles. So again, as I said, air vehicles means any vehicle that flies in air, means that aeroplanes, rockets also considered in air, and the space systems, specifically satellites. And here it is the aircraft. And if you look at the what you need to study, of course, we have the engine here. Okay, so you need to study about engines, which we call propulsion. This is called propulsion. And you need to study the movement of this vehicle in air, which we call aerodynamics. And you need to study the performance of the aircraft. Performance means how the aircraft is taking off, how the aircraft is flying with a specific speed, turning. All this is performance of the aircraft. So this is another field that you need to study. And also aircraft systems and flight control. Of course, the aircraft design is a must. Design here means determining the dimensions of this aircraft for a specific mission, whether it is military aircraft or civil aircraft. So based on the mission of the aircraft, you can come up with a design. And this is what students do in FYP. Some of the FYP projects, they have a mission for the aircraft, and then they come up with the design, and they go into the steps of the manufacturing also of the model or the small aircraft, normally unmanned aircraft. Unmanned is not a full-scale aircraft. And then they fly it, and then they take measurements, and they make sure that they can achieve the objective. Now, this is, for example, the engine. And you can see the complexity of the system of the engine. So you are supposed to study how engines work, how can you design the engine for aircraft, including all components of the engine, and come up with a modeling of the components such that you can actually later manufacture those components. And here you can see this is actually aircraft wing. And also the design of the aircraft wing, including the selection of the material and also determining the dimensions of the wing and the strengths and the loads on the wing during flight. This is all part of your study in aerospace engineering. And also here you can see what we call avionics. This is the cockpit of a civilian aircraft, like Airbus or Boeing aircraft. And you can see all the equipment that you need. Normally, they are used for guidance and control of the aircraft during flight. And you need to study about those systems also in your aerospace engineering. And as I said before, aerospace engineering is for any vehicle that is flying in air or in space. And you can see also helicopter is included, and also rockets included in your study. And we come to the program structure. Of course, I want to go briefly about the program structure. program structure. Okay. Actually, the okay, I'll go back up. Anyway, it's actually 139 credit hours divided into some common courses, Kulliyyah courses and university courses and so on. So here I only show the Kulliyyah courses and the specialized courses. So this is actually common courses for all programs. It's basically mathematics and technology entrepreneurship. And then we come to the specialized courses. Level one, you study like fundamental courses also that you need for the program. And you can see here, Introduction to Aerospace Engineering. This is the first course really specialized in aerospace engineering. And then you go to level two, where we have so many courses now related to the, as we said before, the propulsion, the aerodynamics, the structures, and also the control and guidance. So you can see here dynamics, fluid mechanics, and instrumentations, and also materials and manufacturing is here, mechanics of material, control system, and aerodynamics, and all you can see here related to space mechanics. And then you continue here in level 3, where you get more specialized courses like aerospace propulsion here you study. And also you can see flight mechanics related to the performance of the aircraft. And of course, engineering design ideation. This is a new course introduced in the new curriculum. And different courses related to the aerospace engineering. And then we come to level 4, where you can see here spacecraft dynamics and control. This one also specialized course. And you can see project 1, project 2. And when you go to level 4, you can choose from electives, and this is the list of electives as you can see here. The electives, of course, it can give you more insight into different disciplines of aerospace engineering, like here, more on rocket propulsion. Although you study rockets in the normal courses in aerospace propulsion, but here if you want to know more about rockets, you can take this elective. Helicopter is here also. And then you have composite structures and aerospace manufacturing technology if you want to specialize more, and space systems also, and so on. So you can choose actually 2 courses out of this 10 courses. And job opportunities, as we said before, not only in aerospace engineering, actually you can work in different places. But of course, Air Force, oil and gas company, because your study of moving vehicles into air, this one can work in different places, or you can use this knowledge in different places. You can see here aircrafts, automotive, or train or naval, whatever it is. You can apply your knowledge in those fields also. Of course, the job opportunities, we check with our graduates, and they can actually find job places in these fields. So simulation company, as aerodynamic designer for the automotive, aircraft building, and so on. Aerospace company, helicopter companies, of course, the Air Force, military Air Force, pneumatic and hydraulic, because your study I mean, gives you the knowledge enough to work in any of those places. Of course, examples of the companies are mentioned here. Okay, now I just introduced to you the labs and facilities, and later I will show you just a small video about FYP project of students. Okay. So here the labs for structures. You can see this is related to the structural part, strength of material, and so on. And then we have here the combustion, and this is computer lab. And here we have the propulsion lab, where we have a small models of engines here, small. And then we have the thermal fluid lab. And this is wind tunnel, actually small wind tunnel. And okay, this is also fluid lab. And here wind tunnel also. Okay. And then okay, also structural lab. And this is the wind tunnel. And this is samples of the final year projects of students. You can see building unmanned aircraft that the students actually design and build and fly, okay, those systems themselves. Okay. Okay, actually, just a small video showing the students. So I will stop sharing and then I will share another. Okay, where is it? Okay. Let me share. Stop sharing this one. And then okay. Okay. Okay, that's it from me. And if you have, of course, almost 20 minutes. So anyway, if you have any questions, you can actually chat now or just send me an email to my email. I will respond to your questions. Okay, thank you very much.
Thank you. Thank you, Dr. Mu'min, for the speech, for clarifying the confusions present regarding terms used, and for giving us insights on the program structure and future jobs, and of course, for sharing that inspirational video. Seeing that we have no questions asked in the chat, we will move to our next speaker. I'd like to invite Dr. Helmi Helaladin, the AA of Automotive and Mechanical Engineering. Please welcome.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Can anyone hear me? Okay.
Yes.
Sweet. Oh. Can you try here? Okay, can you see my screen right now?
Yeah.
Okay, so Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome everyone. So my name is Hilmi bin Helaladin. So I am the academic advisor for mechanical engineering program. So I think most, not most, that some, maybe half of what I'm going to, or I won't present here, but half of what is contained in mechanical engineering program, especially on the labs and so on, is we shared together with aerospace engineering. So the Department of Mechanical Engineering, we have two programs, mechanical engineering and also aerospace engineering. So we are one program, one department actually. So all the facilities especially are shared together. So I'll make this presentation as simple as possible. Okay. Now, so okay, I'll explain later on. So this is the Department of Mechanical Engineering. So this is including all the aerospace and engineering lecturers as well. So inshallah, if you come to mechanical engineering, these are the faces that will be welcoming you with a big heart and wide smile for you when you come into the mechanical engineering Department of Mechanical Engineering. Okay. Now, so I think based on the question that was given to us before the expo, especially on the mechanical engineering program, is basically most of the confusion comes from what is the difference between mechanical engineering and as well as, for example, manufacturing engineering, mechatronics engineering, and especially and as well as aerospace engineering. So mechanical engineering basically is a wider, a broader area of knowledge. So mechanical engineers especially are very adaptable to all sorts of area. So we can go into aerospace, we can go into manufacturing as well, we can go into oil and gas, we can go into for example, the audio manufacturers, audio system manufacturers, automotive manufacturers, so all sort of area because mechanical engineering is basically the fundamental area of engineering knowledge. So we are very adaptable to various area of knowledge and area of industry. So, okay. So in this program, or in the Bachelor of Mechanical Engineering program, so this is basically a new curriculum for the Mechanical Engineering program. So we have automotive energy, basically the specialization for mechanical engineering program. So as I think as you might have noticed, especially if you know some seniors, or you have siblings, older brothers or sisters who studied in mechanical engineering program or mechanical automotive, is that we don't have the specific mechanical engineering or mechanical automotive engineering Bachelor of Mechanical Automotive Engineering. So we make it general, so Bachelor of Mechanical Engineering program, which in third year you can choose to specialize either in automotive, energy, manufacturing, or just continue for the mechanical, general mechanical. So we bring this curriculum to adapt to a wider or broader area of industry. So this is basically to adapt or to meet the demand of industry, which, if for example, if we put mechanical automotive engineering, it might limit you to only automotive industry. When we make it a broader mechanical engineering program, you can go into any area that you are interested in, whether it's automotive, energy, manufacturing. Energy basically is oil and gas mainly, manufacturing, and also if you want to go into the more fundamental area of mechanical engineering, you can go into the mechanical engineering, into the general mechanical engineering. Okay, so these are basically the subjects, or the area, the general subjects that will be in the course. So we have on structures. Can I show the spotlight? Is it okay? So so we have in structures, energy, CA in design, dynamics vibration, and IR 4.0. In the specialization, we have general mechanics, mechanical, where we have some thermodynamics, tribology. We have manufacturing, we have quality control, industrial tools, energy specialization, we have energy management, oil and gas industries, energy conversion, and automotive specialization. Basically, we continue from what we have before, which is we have the transmission system, vehicle electrical electronics, system, vehicle design, chassis system, and the newest additional is the hybrid and electric vehicle. So we actually have some prominent lecturers in mechanical engineering, especially Prof. Ataur. So he specializes in electric vehicle. He is in charge with the I forgot the term. The electric coaster is a project which is under the flagship project for the university. And we also have Prof. Masjuki. He is basically the top, if I'm not mistaken, top 10% highly cited researcher in the world. So we have a very and he is specializes in tribology. So we have very prominent lecturers, very prominent professors, especially, and as well as lecturers in the mechanical engineering department. Okay. And we have two research group. This is basically for you if you, for example, you are planning to go into postgraduate. So we have two research group, which is structural mechanics, and as well as thermofluids research group. So both groups are including or shared together with the aerospace program. So both aerospace and as well as mechanical lecturers are combined into these two research groups. So we are very broad in the sense of the research that we can do is very broad. It can be in mechanical, it can be in aerospace, it can be both combined together, and to develop a much better or much broader research. Okay, so in terms of the industry, industrial prospect of mechanical engineering, as I mentioned in the beginning, mechanical engineering is a very broad and is a very fundamental part of the engineering knowledge. So you can basically go anywhere in terms of the industry, and since we make it the Bachelor of Mechanical Engineering, that term just by deleting on just by removing the term automotive in the title of your graduate, you can have a much broader options of where you want to go, where you are interested in, whether you are interested in design, whether you are interested in automotive, whether you are interested in oil and gas, manufacturing. So anywhere that you want to go, anywhere that you are interested in, you can adapt based on what you learn in mechanical engineering as the fundamental knowledge. Okay. And these are the companies involved, for example, involved in mechanical engineering. As I mentioned, we have oil and gas. These are the prospective employers that you can expect. We have oil and gas, manufacturing, construction, marine, industrial power company, maintenance, hydraulic related company, and consultancy. We have prominent alumni that are especially in consultancy area, where they give consultancy to Petronas, to Proton. So this basically shows that our alumni that come out from our university, from our program, can basically give a much more expert advice to the industry. Okay, so the companies involved in this is in automotive engineering especially. So these are all the companies that we have alumni in. So basically, you can say all of the companies that are involved in automotive engineering, we have our alumni in that. Okay. Okay, so other than the studies, we also have, as mentioned, from mechatronics to ECE to aerospace. So basically, we have all our departments have various activities. We have MEXA. You will hear from them later on. We have some visits. This is just a very small program that I am showing you. So there are a lot of other programs, and we also do visits or program together with aerospace students as well. So we have, I think for aerospace, we have Aero something, Aero Society, and MEXA also have joined program together. So this is the electric coaster, IIM electric coaster, which is developed by the department and led by Professor Ataur Rahman. And this we have, and we will continue to develop and continue to improve on this coaster. And we are actually working towards having this coaster being used by students in and around of the campus. And we are still working on that. The actual coaster itself is working very well, but we just need some paperwork to be done to basically use this as one of the vehicle that students can use other than the normal bus to go around the campus. Okay. And these some of the previous activities that we are involved in. This Green Mobility Challenge, Smart Mobility Challenge that we have, and we did one once in 2012. Okay, this is quite a long time ago, but the project itself is still here, is still available, but of course we have to have students to be involved actively. So in order for us to, and we have lecturers that were involved in this project before, and they are very much welcome if students wanted to be involved in this competition again, and basically try to win it again, right? As for IIUM. Okay. So this is the contact person. So Prof. Miftah Harari is the head of department for mechanical engineering, and he basically is heading the mechanical engineering program as well as aerospace engineering program. So he's both, right? And my name, I put my this is this prepared by someone else. So my name is Dr. Hilmi, Hilmi. I'm the academic advisor. So anything you can ask to my email. Okay. So just an additional one info that I think one of you asked, that what is the range of salary for mechanical engineers. So it depends on the area that you are going to. If you are going to, for example, oil and gas, you might have a higher salary. So normally, in general, for mechanical engineers, is around 2,000 to 3,000 for fresh graduate in ringgit Malaysia. Okay, so in RM 2,000 to 3,000. This is in local companies. For oil and gas, it might go a bit higher, maybe around 3,500 to 5,000 for fresh graduate. And I also mentioned about consultancy. So if you are interested in giving expert advice, and you build your own knowledge and your own expertise by taking courses, by taking extra courses after you graduate, especially, and taking licenses, accreditation, and so on. When you work in consultancy, you will have a bigger margin of salary, because consultancy is something that is quite demanded by industries, because the need, other than having their own internal research team, they also need someone else outside to basically take a look at some things that some issues that they might overlook because they are inside. So someone outside might be able to have a broader view of what they are doing. So that's why consultancy agency or consultancy company quite in the rise or quite demanded right now. Okay, so yeah, so that's it from me. If you have any other question, you can ask, I think, in the chat room. If not, you can just email me. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Helmi, for the excellent introduction and for your answer for the student's query. The coaster will be used soon, inshallah. Next, I'd like to invite Dr. Nadia Muhammad Hussein, the Academic Advisor of Civil Engineering. Please welcome.
Can you see my slide?
Yes.
Okay, Assalamualaikum. I am Dr. Nadia from Civil Engineering. Okay, just going to make things very briefly today. Okay, so at the moment, our head of department is Professor IR Dr. Maisara Ali. Okay, right, and for your information, civil engineering is the most youngest department. Okay, it's the most youngest department, and we are basically officially formed in June 2015. Okay, and first offered in September 2015. Okay, and we have that time it was only 25 students. And then we have received AAC accreditation for 6 years, starting from 2019 to 2024. Okay. All right. Our department is not big. Okay. There's only, these are basically our staff. Okay. And then we have new staff just came in last Friday, Dr. Ramis. Okay. All right. And then you need to know what is civil engineering. Okay, this is very typical. It is not just building and construction, because everyone knows that civil is building and construction only. Okay, it is not just that. Okay, all I can say, okay, we have besides building construction, we have geotechnical engineering, structural, transportation, okay, water, environmental, coastal, earthquake, and also forensic. So all students, you have to be, future students of civil engineering, you have to have the idea that civil engineering is just not building and construction only. Okay, it is more than that. Okay, so I can list down at least 9 of the other subsection of civil engineering. Okay, again, yeah, it's not about just building construction. It is more than that. It is geotechnical, structure, transportation, water, environmental, coastal, earthquake, and forensic. So when you take civil engineering in UIA, you'll be exposed in most of this. Okay, except for forensic. Okay, but earthquake, we will expose to you on earthquake during your FYP, and also towards the end of year 4, okay, on earthquake. All right, so for civil, don't expect to work in a cold office, okay, in a nice situation, okay, because this is what you have to go through. Okay, this is basically on construction and geotechnical, right? And this is what basically, if you're doing consultancy, okay, this is what you have to produce, right? Most of the time is drawing and also design. You have to be good in software design. Okay, if you don't like doing software, okay, or you can choose to work in the construction. Okay, but all I can say, when you do civil engineering, Nowadays, you have to be good in software design. This is, for example, of Tekla output for structure. Okay, you should be able to transfer the information from architect to the software, okay, in order for you to design your structure. Okay, so you have to be fast in learning your software because it is very highly in demand. You'll be using this in your IDP, okay, and we expect students to learn on your own, okay, and if you have issues, then you can come back to us, okay. We are not going to give you one-to-one class on the software, okay. So that's why students, you have to explore on your own. Like Dr. Hasma said just now, this is not high school, this is not your matrix. We do not spoon feed you, because when you work later as well, your boss won't spoon feed you. You have to learn on your own. If you have issues, only you can come and discuss and check. Other than that, you have to learn on your own first. Then when you come, you double check with your lecturers or your supervisors about it. Okay. All right. This is another example of civil engineering, water supply, and also sewerage system. Okay, you have to design all this. This is under civil engineering. Okay, water supply and also sewer and also drainage. Okay, drainage system. This is all under civil. And okay, this is under traffic. Okay, or the traffic lights. Okay, you have to decide whether you want to do a U-turn, whether you can do, whether you should do a single lane or double lane, or and so on. Okay, and whether you should put traffic light and so on. Or these are basically under traffic and transportation. This is under civil engineering. Okay. Also, you can also work with with a concrete company. Okay, where all these concrete, right? They will produce a manufacturer, okay, concrete manufacturer. They will produce this concrete and they will basically sell it. So basically, civil engineer, you will learn this during your first year, okay, first year in civil engineering. So they need civil engineer to design the concrete at a certain grade, certain strength, and also this is bitumen. Okay, they also need civil engineer to produce the right or the best bitumen strength. Okay, so all these they need civil engineers as well. Okay, so these are the lab that we have in IIUM. Okay, we have civil engineering lab, soil and geotech transportation, hydraulics, hydrology. We also have design lab. We have light structure as well, survey, and also environmental engineering lab. Okay, so right. This is basically the study plan for 4 years in IUM. You need to have hold on, yeah. Okay, I have a little bit of technical issue. Hold on, yeah.
In the meantime, if students have any questions that they'd like to ask, they can type that in the chat box.
Okay, all right. So this is basically the 4 years of study plan. The study plan for you in IUM. Okay, you have to take about 139 credit hours. 90 core courses, 9 elective, and 6 free elective. Okay, so all these core courses includes structure, okay, construction, geotechnical, traffic transportation, and also water and environmental. Okay, all right, just to share with you, this is our first batch graduated November 2019. Okay, just before the pandemic. Okay, and this one also the second batch graduated. Okay, and yeah, these are basically the activity we did during the pandemic. Sorry, before the pandemic. Okay, we basically did a lot of site visit to various areas. Okay, all right. I check on the question asked. The first, I think most of the question I receive is basically on the salary. Okay, so all I can say, I think Dr. Himi has mentioned just now. If you go to oil and gas, then you will get higher salary. If you're not, then your salary will be around fresh grad. If you're lucky, you're gonna get 2.5K. Okay, which I heard that most of the new generation complain it's not much. Okay, 2.5K for fresh grad. For your information, I don't think you can get rich if you want to be if you be an engineer. Okay, unless if you gain experience, get your PE, and have your own company. Okay, to me, when it comes to me, the first question asked by student about salary, I don't think it's an appropriate question. Okay, if you wanna become an engineer, get your degree, gain experience, 5-8 years, then only you can demand for salary. Okay, if you are a fresh grad, right, you only have your EIT experience, okay, don't demand for salaries. Get experience, 5 years, then only you can demand for your salaries. Sorry, okay, another technical issue. Okay, sorry. All right, so I think that's the first question about the salary. Okay, is there a lot of job application nowadays? Okay, all I can say, Malaysia is still a developing country. Okay, if you see, there's a lot of construction going on, and what I can say, even during the pandemic, most of our students got placement during the pandemic. So I think I can say that civil engineering is still in demand. Okay, as long as the country is developing, there will be still job offers for civil engineering. Okay, some of them got nice placement, like big companies, but to me, big or small companies, it doesn't matter as long as you get the experience. Gain the experience and the knowledge, okay, and like I said, after 5-8 years, you can demand for any level of salaries that you want. Okay, what else? What question? What are the requirements to as civil engineering? Okay, requirement number one, of course, your degree in civil engineering, and if you can along the way get the experience, okay, learn on new softwares. Okay, let's say if you like structure, learn as much as software as you can, at least two, maybe For example, Tekla or Start Pro, okay? So at least 2 so that you can put that in your resume, and you know you can basically sell your resume by telling them that you have experience with using all these softwares, okay? Okay, that's all from me. Any question?
There's no new questions in the chat box.
Okay, thank you.
All right, thank you, Dr. Nadia, for the brief overview. Now, I'd like to invite Associate Professor Dr. Noraili Muhammad Fuad, the AA of Chemical Engineering. Please welcome.
All right, thank you, Sister Iman. Okay, so let me share the screen first. Okay, I hope you can see my screen now. Okay, right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Enginius and also Kexpo committee, okay, for the invitation. And good morning, okay, and I'm honored to be here with the future students of Kulliyyah of Engineering. Okay, my name is Dr. Noraili binti Muhammad Fuad, or students know me as Dr. Ili, and I am currently the academic advisor for Department of Biotechnology Engineering. So inshallah, in this 20 minutes, I'm going to introduce you with our program, Bachelor of Chemical Engineering. So if you see, okay, here our department's name, okay, you might be wondering why our department's name is not similar with the programs that we are offering. Okay, so let's look at a bit of a history. Okay, so Alhamdulillah, all of our engineering programs, okay, are recognized worldwide and accredited by the Engineering Accreditation Council. Okay, this is important to ensure that the contents of our program or the courses in our program are relevant and up to date, okay, with the current industry demand or future industry demand as well as the society. So if you look back, our department had a first intake in 2000, okay, under the name of degree of Bachelor in Biotechnology Engineering. Okay, and then in 2003, after accreditation, we did a revision, okay, based on the advice from the EAC panel, okay, which changed our name to Bachelor in Biochemical Biotechnology Engineering. And if you can see here, from 2010, okay, until 2018, we had revised our curriculum twice, okay, and last year in 2020, based on the accreditation in 2018, we make a big decision to, of course, to revise the curriculum and also to change our program to chemical engineering. Okay, and alhamdulillah, we had our first batch recently, okay, in semester 2 with under this chemical engineering program. So some might ask, what actually the difference between chemical and biochemical engineering? So they don't have much difference actually. Okay, biochemical engineering is actually under chemical engineering. Okay, chemical engineering has a few branches, okay, such as petroleum and some other has been defined by the Institute of Engineers Malaysia. So biochemical is one of the branches. So we want to, we hope that by the rename and also the revision, it might increase the employability of our graduates. Okay, I don't say that previously we don't have employability, but alhamdulillah, our graduates managed to get job from many industries, even in oil and gas, even with the name of biochemical engineering. Okay, so we want the future employers to see our graduates with the broad aspects, okay, compare under biochemical. So what is chemical engineering? Okay, what is chemical engineering? So chemical engineering is basically a multidisciplinary branch of engineering, okay, where you can see here it's integrates, okay, the knowledge of experimental science such as physics and chemistry, okay, with life sciences such as biology, microbiology, and biochemistry. And of course, when you talk about engineering, you cannot run from mathematics, okay? Because some of you, I think some of the question ask, you know, which branch has a least mathematics? No, when you are in engineering, you have to, you know, you have to accept that you will deal with the mathematics, okay, for different applications. So you will incorporate all this knowledge, okay, chemical engineering with the mathematics and perhaps some of economics aspects, okay, in order to transform, to produce raw materials, certain raw materials into useful products in many applications. Okay, if you can see at the right side here, okay, it can be in foods, okay, materials, and so on, even in energy, okay, environment, and also chemical engineers can contribute, okay, in the health sector, okay, production of pharmaceutical or biopharmaceutical products, okay, diagnostic tools, and also devices. So in a simpler word, I would say chemical engineers will basically develop and design process, okay, to produce certain products, okay, either to improve the process or you want to create a new one. Okay, so let's look more. Okay, if I want to, you know, to show everything, the courses that we offer, it might take a long time. So I want to highlight, okay, the courses that we have in our chemical engineering program. So I put the photo here, okay, just to make, you know, you see the application. Okay, one of the application of chemical engineering will be in the food process. Okay, if you can see here, what, to produce cheese, right? Okay, produce cheese, okay, where the raw material is the milk. Okay, so you can see that in order for the milk, okay, to transform, okay, to into cheese, okay, with certain structure, certain taste, and also shelf life, okay, it will undergo several processes. I mean, a number of processes, depends, okay, be it pasteurization, okay, some separation process, and each of these process will have their own conditions, characteristic, and etc. Okay, so the programs, among the programs that can, among the courses that you can relate, okay, with this application, okay, we have separation processes, okay, and of course, food process engineering is much relevant because this is for producing food, okay, and then reactor design. Of course, when you want to produce you know, in large amount, okay, you need some, you know, equipment, okay, or you can say where the reactions occur, or you call it a reactor. So you need to design it, okay, according to how much you want to produce. So you will learn this in the reactor design. And yes, when you do transformation, okay, there's some reaction changing one state to one state, okay, from raw materials to one product. So you have to study reaction engineering, okay, and another course which is very important, okay, as I said, when you want to have the whole process, okay, it is inside a plant. Okay, what is plant? Plant bukan yang tumbuh-tumbuhan tu kau, pokok tu semua. Okay, plant is where all these equipment process are located. So as I said, okay, if you ever heard about pasteurization, okay, this process is conducted under high pressure and high temperature. Okay, so you need to know what are the materials that are suitable, okay, to design your reactor for this pasteurization, okay, to stand with the high pressure and temperature, and of course the safety. So all this you will learn in the chemical engineering, and you will apply all this knowledge in your integrated design project. You will be given a project, okay, to produce something from certain raw materials, and you need to, you know, in a group, okay, you will, you know, design your own unit operations that have certain functions. Okay, so what's example? So another, okay, almost the same courses you can, now you have what? COVID-19, okay, vaccine. So chemical engineers can also contribute in vaccine production, especially when it comes to produce it in a big amount or large scale production. So that is actually Enginius' job. Okay, you can choose whether you want to focus in the upstream process, means start to produce the product. Okay, vaccine, I don't want to talk a lot about vaccine here. Okay, but you can see there's actually, when you want to produce vaccines, there's a lot of unique processes involved. That's the opportunity where chemical engineer can chip in. Okay, start from the product development until the process to produce it itself. Okay, what we call as purification process. Okay, and another specialization that we also have, okay, in chemical engineering is on environmental. Okay, it's also one of the upper branch under chemical engineering. Okay, if you ever heard about waste, from waste to wealth. Okay, so chemical engineer, okay, is, you know, convert something. You can convert the waste, okay, usually biomass waste. Okay, you have many agricultural residues which are underutilized, and if we let them, you know, to decay, they will produce some greenhouse gases, okay, that will harm the environment. So we, as the chemical engineer, we can, you know, create a process how to convert all this biomass into useful products, okay, such as biogas, okay, renewable energy, also some materials or some useful chemicals. So you can see these are the courses that we have. Okay, then when you have this process, okay, each of these unit operations, surely that it will produce some waste. So how you can manage the waste? Okay, so you will learn about it as well, okay, under our program if you are into environment specialization. Okay, so basically we have three specialization in our program. First is product development, second one is on the process, and the third one is on the environmental. Okay, all right, so what are the career prospects, okay, for chemical engineering program? So you generally are chemical engineers, but you can work in many sectors or having different designation or different roles. Okay, first, yes, if you interested working in the environmental area, you can be as an environmental engineer. Okay, yeah, then in the food or production engineer, okay, in any manufacturing, the process itself, you can contribute to that. And yes, process or bioprocess engineer depends if the company is working with using biological agents such as microbes or animal cells, okay, or fungi to produce certain products, then it's bioprocess engineer. So if it's a purely chemical reaction, so it's process engineer. Or if you don't want to involve with engineering, okay, you are more working hands-on in the lab, you can be a scientist, okay, which is called as biotechnologist or chemist, okay, or design or analytical engineer, okay. It's not only an experiment, but you know, a chemical engineer also works with different labs, different software, simulation software. So you can also work in that area if you are, you know, interested working with the software simulation and so on. And lastly, okay, for the health sectors where in pharmaceutical or biopharmaceutical engineer. Okay, so let's look at where our alumni now. I just want to highlight, okay, bear in mind this is not represent all the students that have been graduated, okay, from our departments. Okay, this is some of the data that I managed to get. Okay, so where are our alumni now? Okay, some of us, okay, when I'm talking about us, I'm talking about me as well. I am graduated from this department in 2007. Okay, and I decided to pursue my postgraduate studies. Okay, and some of other alumni as well. So now some of us working at the national universities, and some international students are also working at the other international universities abroad. Okay, which I cannot list here. Okay, you can see various universities now. Okay, and some of our alumni are at the food industry. Okay, Gardenia, Mami, as you can see here. Okay, some example in Mami. Okay, our alumnus there working as a QA and QC. Okay, quality assurance line. Okay, and some of them in the process itself, special Malayan fish oil, okay, involved in designing the process to extract, to purify this fish oil, okay, which will be exported to other countries. Okay, some of them also working at the pharmaceutical companies. Okay, Pharmaniaga, I bet you have heard about this before. AV Manufacturing is vaccine company, producing company. And yeah, sorry, it's a bit here. Okay, this is a biotechnology company. Okay, InnoBio, and Biocon is a biotechnology company from India. Recently, we had, I think there was one batch graduated in 2018. We had more than 5 of them working there. Okay, and some of them who did masters first with our department also got a job offer after they finished the master. Okay, under this company. Biocon is producing insulin, okay, for diabetic disease. Okay, then others, this is environmental. Okay, you know Samdabi. Samdabi has many industrial activities. One of them is palm oil industry, right? So they have a lot of waste, okay, palm oil mill effluent that they do research and converted it to something useful, such as biomethane for the energy. Then you have other industry, Siltera, okay, semiconductor industry. This is chemical. This Recron, if I'm not mistaken, producing PPE. Okay, then we have also Germany company that produce medical supplies. Other than that, also you can be a researcher. Okay, our alumni is researchers at research institute or government link company. Okay, LGM, ABI is Agro Biotechnology Institute. Okay, then we have also, okay, as I said, some of our alumni working with oil and gas company. Okay, international, Baxter, Halliburton, what else? This is Abu Dhabi. Okay, Shell, and then yeah, Top Glove. Okay, we also had many alumni working there, thanks to your seniors who, you know, show a very good performance that make the company to have trust in our graduates. Okay, and as example, my former students who is currently doing EIT, internship training at Top Glove. Okay, while she is doing her internship, she has been offered to work there in Top Glove. So immediately in 2 weeks after she finished, you know, her degree, she will start working with Top Glove. Okay, so this is just want to share our, of course we have very successful story of our alumni. Okay, this is the latest one. This is last year. Okay, in 2020. Okay, where nowadays when they are, everything is working with COVID-19, right? Whatever related with COVID-19 is nearable now. Okay, our student here is Dr. Yusuf Johari. Okay, I think he graduated in 2008, if I'm not mistaken. Okay, he is now one of researchers at the Department of Chemical and Biological Engineering at the University of Sheffield. Okay, his team successfully manufacture okay, the spike protein of the COVID-19 virus. If you know COVID-19 virus, one of the specific or unique characteristic of this virus is they have the spike protein that if you can see from the ni kan yang terkeluar tonjol ni. Okay, so this is the spike protein that, you know, you can identify whether you have the infection of COVID-19 or not. So they manufacture this spike protein to be used for the antibody test. So I think this is quite a big success, okay, for the alumni to be involved in such big project. Okay, so we are also inviting our alumni, okay, to have a sharing session with the current undergraduate students, so that, you know, our students are exposed, okay, so that they have an idea what actually chemical engineers can do. So this is the recent one, okay, when we have, okay, one of our alumni who work with the Biocon, as I said, okay, biotechnology company. He got an offer immediately after he graduated. Okay, so you can see here that already 2 years he's working, okay, to produce insulin, where, okay, his job scope, you can see here, his job scope is only on the solvent recovery plant. Because when you do some chemical process, okay, it will involve many chemicals, and some of the chemicals are very expensive. So in some of the companies, they will, you know, recycle, use back the chemicals. So this guy, okay, Brother Afiq actually in charge, okay, on how to recover that solvent. We also have, this is our alumni, okay, work at the NB Research, okay, give a talk to the student as well. And this is one of alumnus who he opened his own company, okay, being a consultant, environmental consultant, Brother Miftah Salihin. So this is what, like Dr. Nadia mentioned before, if you want to be rich, okay, you gain experience, okay, you get your professional engineer and open a consultant company. So then you can be rich, okay, by taking this engineering degree. So this is what our alumni, okay, did. Okay, and also we had our alumni from currently working at Institute Technology Bandung in Indonesia. Okay, and also another example, okay, this working with Silterra. Okay, he has been working with Silterra for 15 years, okay, since he graduated. Now his current position is as senior engineer, okay, for the ultra pure water treatment system. So you can see specific, he is taking care for the ultra pure water treatment system that is used to produce the semiconductor. Okay, Silterra is the semiconductor company. So he's taking care to do the operation, okay, audit, cost management, and so on. So you can see that what the job scopes, okay, the prospects of chemical engineer. Okay, so that's all. These are the current staff. I think we have 24 academic staff currently. Okay, of course, with more female staff, okay, compared to male staff, and of international students. So that's all from me. Thank you.
Great, thank you, Dr. Ili, for the very detailed and enlightening speech. Right, for manufacturing engineering, I'd like to invite the academic advisor, Dr. Nur Khairul Muhammad Khairul Saleh. Please welcome.
Okay, Assalamualaikum all.
Waalaikumsalam warahmatullah.
Alright, so first of all, okay, my name is Dr. Nur binti Muhammad Khairul Saleh. Currently, I'm the academic advisor for manufacturing engineering. Okay, so can we call it still morning? Yeah, still morning, 10:30. Alright, so as an introduction, let me go to the question first. Is it okay? Yeah, so the question first. Okay, so the question, like when I go through to the question, seems like the question is, you know, similar with other programs which has been answered by the other academic advisor. And then one of the interesting question there is what branch has the least met? Okay, what branch has the least met? Okay, from my understanding from the question is that you are asking in manufacturing program which area that practice less math. Am I right? Okay, so when you are already engineering student, basically you are practicing a very basic math, okay, in the manufacturing program. Okay, so let's see, when I ask our PIZ here, Sisi Iman Jamil, right? Sisi Iman, correct? So if I said, sister, can you give me the answer, what is 10 minus 2? Can you easily answer it?
Yeah.
Right? Okay, however, okay, hold on. Okay, it happened because it's on Sunday. Sorry, guys. Okay, so come back. When I ask our PI here is 10 minus 2, so easily you can answer it equal to 8, correct? But if I ask to others, maybe to kids like standard 1, if I said what is 10 minus 2, maybe they take time to, to think about the answer. All right. So in manufacturing, same. Okay. So basically, we are practicing all the basic mathematics formula or knowledge. All right. So, for example, even though in the quality as well, you also have a very simple mathematics used in the, in the machine learning as well, in the management as well. Okay, all right. About the salary, like Dr. The academic advisor from Civil explained, it depends on the area that you are working. Same with Dr. Helmi just now, right? So if you are engaged with the oil and gas, it might be higher. But averagely, what I can say that for the manufacturing industry, as a graduate from mentoring program, you can easily can have like 2.5K as a beginner. All right, and then what else? I think maybe our IC can share that the video that I prepared for this program. Okay, I made a video, a very short video for you, so that please enjoy the video. I hope it's okay, and I believe it's answer most of the questions that you already sent to the committee.
Can you guys see the video? I mean, a screen is currently black, but I'm going to play.
We can see your dark blank screen.
Okay. I'll start playing it now.
I cannot say anything, but is it my internet or?
No, the audio is playing, but
the view is not there, right?
Yeah.
I can see the screen. Can you start again the video, please?
Okay, sure. I'm sorry.
Okay, I hope you can enjoy the video. Okay, thank you, Shamiti. All right, so again, there's a question asked, manufacturing, is it under mechanical? Yes, in manufacturing is one of element under mechanical engineering. So under manufacturing program, we are practicing 70% of mechanical. So like I said that you will not have no problem to find a job or job opportunity in mechanical area. And I would like to stress on that IIUM is the first university that offered manufacturing engineering in Malaysia. Right, and then from the latest record that Alhamdulillah, most our graduates from the manufacturing program already have been hired from the industry outside. Alhamdulillah. Okay, so I think that's all from the manufacturing. Maybe you have a question, we can ask now, or maybe you can write at the chat box. Any question? No question?
No question.
All right. Okay, so I will write my email at the chat box. So if you have a further question, you can just email me. I will reply as soon as possible. And I think that's all for me. Just a very short, and I hope it's a very brief and details about the manufacturing program. Okay, thank you.
Thank you, Dr. Nakharishima, for the excellent introduction with the video. Next, I'd like to invite Dr. Faradiana Muhammad Daud, yes, the AA of Materials Engineering, to give a brief overview of the major. Please welcome.
Okay, Assalamualaikum and very good morning. You can hear my voice, Iman?
Yep, clear.
Alright, okay, thank you, Iman. Okay, first of all, I would like to thank to the engineers for invite us as a speaker for this program. Okay, I'm Dr. Farah as what we call the academic advisor for material program. Okay, today I just would like to give you some brief about idea what is about the material engineering. Okay, let me share the slide first. You can see my slide?
Yeah.
All right, okay. I'm Dr. Farah as academic advisor. Okay, first let me introduce to you what is a material engineering. Okay, material engineering, as you know, is actually it's a backbone to the other industry, or we can say as the what we call the fingerprint to all the innovation in the industry. Okay, we as material engineering normally we will what we call explore or investigate on the understanding about the material processing, as well the called the structure, property and performance of the material before can be used for certain products. Okay, you can see here we have as a material engineering also we have used to advance understanding in a various research area. Okay, we have like nanotechnology, we can have renewable energy, advanced composite biomaterial, as well metallurgy, and many more interesting application. All right, you can see here we as a material engineering we have most of our graduate, they have the what we call the opportunity to various industry, as well as entrepreneur consultant, as well as the education research, meaning they can be as a researcher at the what we call at the research center, and also they can pursue study at the overseas as well. Okay, I try to play this video. From this video, actually there are quite a new video from the Nanyang University Education from Singapore. Try to play. If you can hear, please let me know. You can hear this? You can hear the sound?
Can hear the sound, but the screen is not moving.
The screen are not moving. Okay, I stop. Okay, all right. Okay, this is about the material science engineering from the Nanyang University. Hope you can get some idea.
Create new materials on demand to solve the particular problems which cannot be solved with the usual devices. So we request more and more from our materials to be smart, to be adaptive.
But it's not very clear.
Yes?
We can't hear the audio clearly.
It's okay. I just but still can hear the sound, right? But not
Yeah.
really clear.
Uh.
Alright. Okay. It's okay. I just to highlight.
And engineering is a so that's quite important. Opportunities out there once they achieve the mastery of materials. The way how materials actually act in the nano scale is completely different from almost completely different from how they act in the macro scale. So that's quite interesting. Like the other same material, right? But then for example, like gold nanoparticles are red, and gold in like macro scale is gold. So like whoa. The other nice thing about the material science and the engineering department is that we have a very high classes that students are our future classes that students are exposed to. Material engineering becomes more and more important for our future technologies. And I think that in the next 5 or 10 years, this trend will continue and will focus in modern architecture. And I mean, either electronic architecture or advanced engineering architecture will be shifted towards material architecture, towards advanced adaptive materials.
Okay, yeah. I cannot do that. Kejap. Alright.
Developing a new type
This video you can hear? Can we do Iman? You can hear the sound? It's okay. I will play after this. I'll proceed with the slide first. Is it okay, Iman?
Yeah.
Alright, I think better. Right? Okay. Okay. This slide show you some what is a new material. Actually, new material. Actually, we call that as a material engineer. We have learned about the new material related to the growth, prosperity, security, new technology, and multidiscipline as well as quality of life. You can see surround you all we have is a various kind of the material. Actually, this new material they are called open the door to the new technology. Okay, either in the mechanical, either in the biomedical, electrical engineer, civil, chemical, construction, nuclear, and also agriculture application. So so far we can say that material graduate, they're able to work in various kind of the application and areas. Okay, as an engineer of material engineering, normally we understand what we call the relationship between the property, structure, processing, and the performance. Meaning we as a material graduate, we able or we can involve or can work either at the what we call at the early stage of the product, and during the processing, and also at the end of the product. Okay, so we can say as a master of engineering universe, right? So without material, the rest of the application cannot cannot run successfully lah, right? Okay, here's some of the subject or some of the area that we'll cover in the our campus for the material engineering program. Okay, we will learn about the advanced materials, polymer, ceramic, and also metal and as well other materials, metallurgy and corrosion. We also have about coating and ceramic biomaterial, the material that we use for implanting our body. Okay, we as a material, also we can involve in the development of material like we call the like our previous my previous researcher about the titanium oxide or hydroxide apatite that we can implant in our body. So we can relate in the various kind of the industry. We have also in the polymer and composite, and also currently we are focused in the simulation and modeling of the material, like we using the COMSOL or using other software in order to study the properties of the materials. Okay, here you can see the we call the job prospect, or we can say career prospect for the material engineering. Okay, Alhamdulillah, for our graduates so far, they are able to employ, like we can see here in during 2008. Okay, for the material program, we can have a high employability of more than 80%. Okay, for last year, 2019, we also able to achieve 81.8%. Okay, for our student graduate, normally they can work in the material engineering and technology industry, and also in the life science or healthcare or biomedical company, transportation, also as the aerospace company like and then microelectronic company also, they can get a job in the oil and gas, petrochemical, energy, research institute also. Some of them are work in the nuclear Malaysia or SIRIM or AMREC. Okay, they also work in the oil and gas or petrochemical like in the Petronas, Shell, and also in the automotive company like a Proton. Okay, we have our graduate here, and also in the Produa, and also in the electronic company like Intel Technology. We have in the Western Digital, for the aerospace company like CTRM Aero Composite in Malacca. We also have our graduate work here. Okay, and also in the many more companies. Okay, so far what we can say, this material engineering, they have a very wide range of the career opportunity. Okay, if you see in the what we call any workable application, they require functional materials, and also most of the every engineering company organization, they require material engineering in their team. Okay, we meaning we also can work as a quality at the early stage of the production of the material. Okay, as a quality engineer or quality assurance or quality reliability, and also as the safety engineer. Okay, and also during the processing also we can have a product engineer. Okay, the skill that you gain in the material engineer, actually they give you a chance or open your door to many of sector. Okay, and put you at the forefront and many new technology development. Okay, I have have some figure. This also summary for the job scope that you can achieve or can get for the after you graduate. Okay, actually they are very broad, meaning you can go any most of the application they have the material part. Okay. Okay, I share you some of my alumni that have successfully get a job after a graduate. Also, we have our material engineering student at the third grade company. All these are material engineering. They have like a group, one group in the third grade from the material engineering from the IIUM. Okay, I'm very happy for them. Okay, and then we also have the other student in the steel structure. This one, they are a little bit different from the material, but they managed to get the job. So they draw this one like a simulation for the building component. And also we have in the Nihon Super Japan into as the manufacturing engineer. Okay, these are brothers as one. So they have their meaning they involved in the production of this product. Okay. And also this one of my FIP student. He works in the what you call in the ceramic ware or dining wares in the Mayo Turkey is one of the Japan company in the Kulliyyah, if I'm not mistaken. Okay, during his working there, they send my student to the Japan for the training. It's quite a good opportunity. All right. Also, we also have these are my colleague, same batch with me, Brother Burhanuddin. Before this, he worked at the oil and gas company, but currently he managed to have their own company, and meaning they have collaboration with the Manson International Limited Company, more on the consultancy and project management service for the subsea oil and gas construction. Okay, these are some of the projects that have been done by Brother Burhanuddin. The location will be in the Bangladesh. All right. So this kind of job is a quite high high salaries, but of course you need to sacrifice your family. Okay, you need to stay there. More on the overseas instead in Malaysia. Okay, these are our alumni also. Brother Ammar Hamzi, graduate 2030, being the API inspector and QC supervisor at the Azam Mobile Company. Okay. Okay, we also have brother, sister Jajarina here, one of the I think women that have involved in the oil and gas company, right? She graduated 2009. Okay, currently in the innovative oilfield service Sdn Bhd, current Shell Sdn Bhd. So one of the meaning the company collaboration company with the Petronas Malaysia. Okay, we also have our pioneer, our first batch of material, Brother Muhammad Rizwan. It's the first batch. I think that time we have only 4 students material engineering. Alhamdulillah, currently we have many students that taken the material engineering program. Okay, they have been the lead piping engineer. Okay, at the Petrofed company. He also have been worked at the outside of Malaysia at the meaning not only in the Malaysia. Okay, here we have our graduate also in the Intel. So for the material also, you can work at the electronic company like the Intel as here as a process and equipment engineer. Brother Fitri here, they work there in the Intel, and then he managed to get the scholarship from the GPA to pursue study at the UK. After that, she already returned back and worked at the third glove company. Okay, we can see the previous slide. Okay, and also we have this other area in the process engineer and final assembly in the SGM management Sdn Bhd, our 2009 best student, the sister Uswata. Okay, so I think quite broad range of area we can work as a material engineering graduate. Okay, we also have students in the research center, meaning like this brother Helmi. I think he successfully finished a master program at UKM under the Institute of Microengineering Nanoelectric IIUM UKM. Okay, and during the master study, he able to go to the National Institute of Material Science in Japan. Okay, currently I think he just started pursue the PhD at the same institute at the UKM. I think and then we have sister Dalila Shaira. Is one of the our alumni 2007 who at the Porter Holding until now. I think she still work there as the engineer. So and then we have also our alumni work in the construction for the LRT3 new grinder project. This is Brother Husaini. This one batch 2019. So I think quite broad the area that material engineering can be involved. Okay. We also have our student that was study in the UK. You can see the overseas like Nanyang University of Singapore or the UK University of Sheffield or University of the other university in the UK. They are very well known about the material engineering program. And also this Dr. Sazwani also already come back after doing PhD at the University of Manchester. Before that, I think she also studied at the USM Penang under the School of Material and Mineral Science Engineering. Sorry. Wait, Wait, Sister Iman, I just another one or two slide. Okay.
All right, madam.
Maybe error. Okay, I left another one or two slides. Okay, this also one of our student alumni, Dr. Laila. She have also studied in PhD in Nagaoka University of Technology, and previous last two year she have been do a postdoc at the Tokyo University. Okay, so here they have some share me some video of research at the Tokyo University as a postdoc. Okay. Okay. Here the list of the academic staff for the material engineering. Okay, they have various research areas. Okay. We have Dr. Prof. Sofian, and also we have from Malay, Professor Hazlin and Professor Zuraida. And also we have Dr. Hanapi and also other new lecturers. Okay. Okay, here's some of the activity. We have Green Material Days. Okay, have been done in the during 25th anniversary at the UIA Gombak. Okay, we also have alumni career talk. Okay, material lecturer competition, and also we have career talk by our alumni in the oil and gas industry last time. Very successfully program. Okay. Okay, we also have some industry visit to the company. Mentor-mentee program for the material and the manufacturing program. Okay, we have student exchange also at the Hokkaido University, Japan. And also we have Nano Malaysia signing ceremony. And also we have collaboration with the other university in the Indonesia as well as the Japan. Okay, I think that's all for the material engineering program. If you have any question, you can contact me as an academic advisor. And also you can visit our website and Facebook page. I think that's all for my part. Okay, thank you.
Are you going to play the video?
The video, wait. You can hear the sound, yeah? Can hear the sound?
We can hear it, but it's not clear.
Like, but still can see, right? Okay.
Yeah.
Okay, I just play first. Okay. This one just to show you about the materials.
Materials engineers and materials scientists have existing ones, materials scientists focus on the structure and properties of materials, while materials engineers apply that knowledge to develop products. Both usually specialize in a principal material, such as ceramics, glass, metal, or semiconductors. Materials scientists improve materials such as metallic alloys or superconducting materials so that products can have features and functions that were not possible previously. They also develop new materials. Materials scientists conduct experiments and analyze their results. Materials engineers select materials for specific products and develop new ways to use existing materials, continuously designing improvements. They prepare proposals and budgets, analyze labor costs, and may supervise technologists and technicians. These professionals team up with other specialists and generally work in offices, manufacturing facilities, or research and development labs. A bachelor's degree in materials science, engineering, or a related field is needed for entry-level jobs. Materials scientists may also major in chemistry or physics and may need a master's degree or a PhD and significant work experience to qualify for some jobs. A graduate degree allows an engineer to work as a college-level teacher or to do research and development.
Yeah, I think that's all for my part.
All right, thank you. There is a question here, but I think you already answered it in your slide.
Yes.
The question is from Sister Noraina Hamiza. She said, is there any opportunities to go offshore in materials engineering? Just now,
Yes.
there was this fight for oil rig, right? Is there
Yes.
anything you wish to add?
I think I think it's a we have as a material grader you have the we call the chances to involve in the oil and gas company. Okay, this is one of the example like Sister Jajarina. And also we have Brother Ridwan in the Petrofed company, and also we have so far when you do for the interview for the Petronas or Shell, the material engineering still meaning one of the able to attend, meaning to have a chances to get the job there. Either in the failure analysis also material engineering, we also have been learned detail during the our study. So I think we still have same chances with the other majoring. All right. I hope I answered the question.
Yes, inshallah. Thank you, Dr. Faradiana.
Okay. How to stop the I cannot close this. Okay, stop sharing. Okay, all right. Okay.
All
Thank
right.
you. Okay.
All right, thank you, Dr. Faradiana,
Okay,
for
most
the
welcome. All right.
overview. Dr. Shima and Dr. Hasma put their emails, they had put their emails in the chat box if anyone wishes to contact them. All of that was the introduction of all the engineering majors offered here at IIUM. Right now, I will open the floor if any academic advisors wish to add anything else. If there's any.
Okay, Assalamualaikum again. Alright, so I would like to add something on the manufacturing since I'm not sharing any slides now. Video. So the one that I want to add is I forget to share with you that the common also offered the expertise in nations and even the machining industry. And another question been asked. Is it manufacturing only involve the surrounding, the work job scope is on the machine, not with the human being. Okay, so in manufacturing, like I said, we also have the quality. Okay, so we have the management. I believe as the student also, we need to learn how to manage our daily life, right? So I think that's all from me from the manufacturing part. All right. So like our PIC already mentioned, I already paste the email there in the chat box. So if you have any further question, you are most welcome to email me and I will detain you on the email. Okay. Thank you, Sister Iman.
All right. Any other lecturers? Academic advisor? All right, then that will be all for the introduction from the academic advisors. A huge thanks to everyone. But before we move on to the next session, we'll have a short photography session to remember this memorable event. It would be great if everyone can turn on their camera and smile brightly. Oh, I'm sorry, give us a moment, yeah?
Okay, 1, 2, 3. Okay, freestyle. 1, 2, 3. All right then.
All right, thank you. Thank you to all the academic advisors and the representative academic advisor. You all may leave the meeting if you so wish. You're welcome to stay. Many thanks and appreciation for making the time to join us this eventful morning. Okay. Now we move on to the second slot, which is the presentation as well, but from the Department Council. Without further ado, I'd like to invite the representative from DC of Mechatronic Engineering to give a brief introduction of their department. Please welcome.
Thank you, Sister Iman Jamil. So, I'm going to share a slide. Okay. Assalamualaikum warahmatullahi wabarakatuh. So, my name is Naufal bin Mufti. I'm as the chairperson of President Mechatronics. So currently I'm taking a second year in Mechatronics, second semester. So basically, what is Mechatronics? Mechatronics is where we students are taught with multiple skills such as mechanical, electrical, computer sciences into one course. So it is like multiple courses in one department. So you can follow us on our social media, ctsa.ium. So you can keep it up with our programs, upcoming programs. For the introduction, so basically what I said before, mechatronics is actually an integrated education encompassing electrical, mechanical control, and computer engineering disciplines, which enables its graduates to acquire the needed skills in facing the challenges of contemporary industry. So basically, mechatronics, we learn about sensors, including cameras, computers, single-board computers, microcontrollers, actuators, motors, pneumatic cylinders, Robocan catapult, such as Robocan catapult. So what we are currently doing in our Robocan. So and then intelligence, decision making, so such as artificial intelligence. And then the last one is communication between robots and computers. So we can have such a like as some robots in our industry. So we can learn about it in mechatronics. And then, so where are mechatronics being applied in our industry is basically like autonomous ground vehicles, in airplanes, it does not limit into not autonomous things, but electronic things on home appliances like vacuum board, fridge. Like so we know that Samsung have created a system like some smart home system that is mechatronics engineering being applied, so they can apply Internet of Things or IoT that connected between devices, smart devices with internet through cloud data. And then the next one in industry, we have automating repetitive tasks, like quality control here. We got the gloves being rotating around the industry field. So when the workers are just sitting, because the machines are just spinning the task, so they can do it again and again and again without having to move much. And then the one is total price detection based on vehicle types. So basically what I said before, in mechatronics, we learned about sensors. Sensors like IR sensors. So we have here RFID sensors like in our tools, our radio sensors, LiDAR sensors that is being applied in autonomous vehicles and such. And then what is the career opportunities for mechatronics engineering graduates? Basically in semiconductor companies, we have we call that opportunities in free scale semiconductors, furnaces semiconductors, Intel and Texas Instruments. Basically, we have in about microcontrollers, conductors in our mechatronics, so we can apply in the semiconductors industry, and then manufacturing, like we see before, the glove, the rubber glove, can manufacture a robot or a mechanical system, so we can ease our industrial system. And then the third one is food and beverage, like the Nestle, Nutri-Freeze, Golden, Jomarina. We can basically build a system to cook foods that is being regulated in specified condition. So we need to have a specified heat and temperature, specified humidity in our in our factory. So we need to control all the ecosystem in the industry. And then the fourth one is control and automation. Control and automation, basically like the Tesla, that we apply automation system that is a building of machine that is controlled by itself using artificial intelligence that is connected by multiple sensors. So they can detect and they can use all the inputs in our data, in the cloud data, and then they will use the algorithm by itself and then discover it by using certain algorithms. And then the last one is oil and gas. We can also use or apply our mechatronics engineering in oil and gas, such as Petronas, Petrofac, Shell, UMW, oil and gas. Basically, we have graduates that pursue in oil and gas. And then the last one is transportation and logistics. So like Malaysia Airlines, AirAsia. So like in aeroplane industry and also in automotive industry, we can apply mechatronics. So this is one of the career opportunities that we can gain from learning mechatronics engineering. Basically, mechatronics engineering is a basic engineering in our industrial companies. So we have graduates in Petronas, Shell, Sony, Toshiba, and others. So basically, don't assume that we are just small graduates that is being learned that they learn just a simple things, but basically we apply in other industry also, like oil and gas, in electronics, in communications like Macy's and TM, in semiconductors company like Intel, and then in automotive company like Proton and Produa, and others like electronics like Sony and Toshiba. So what is the duration of study of mechatronics engineering? Basically, we have like 4 years, and then for one semester, I think we will have 1 or 2 semesters. We have what do we say? The training program that will be taking in third year, second semester. And then what is the maximum period for completion of the program is 12 semesters, or if you want to take short semesters, like in the third semester, so we can add up to 12 semesters. And then, so in mechatronics engineering, we have Mechatronics Students Association, which I am currently holding the position as the president. So it is a society of mechatronics students which organize students and events within the Department of Mechatronics. So currently in the online situation, in the pandemic situation, we have an online session only. So we don't have physical activities yet. So we have like machine learning with Python in our previous workshop. These are our programs in our previous weeks. We have machine learning for image analysis, and then we have mechatronics mass gathering hard session. It is not in physical session, but it is in online session, which lots of lecturers and students helping the students to understand what is our course about. And then the last one is web development workshop, which governs a topic about how to develop a web using a simple software. So I've covered lots of program. It is not just this small program. And then don't forget to join us or apply in the next tenure to join the Mechatronics Student Association, so you can get lots of benefits in our societies. Then last one is I want to talk about roboting club, which I currently join. So in the roboting club, currently I'm joining the Robocon competition, which will be held in October. So why I joined the roboting club is to apply my mechatronics courses that I've been learned. So using Arduino and stuff. So you can enhance your skills in the robot team. So why you should join in the robot team club? Because we have involved in much more robotic competitions. So if you look up in the Google, if you Google it up, robot team IIUM, we have lots of multiple competitions that we have been joining before the pandemic. And the current pandemic, we are joining a Robocon contest. So what we have here is Malaysian Robotic Challenge MRC. We previously won as a first place, and then the second one is the Robocon competition. The one is organized IRC competition, which is in an international level. The fourth one is T Robotics Underwater Challenge. In the robot team, we governs lots of skills such as mechanical skills, in computer science skills, and then in programming, in building the circuits. So we govern lots of skills in our robot team. So you can connect with more people and you can learn lots of skill. And basically in industry, they search for Robocon students to be recruited in their industry because they know that Robocon students are capable of doing jobs. And then the last one is you can learn new things. Like I said, you can learn new things in the roboting club by exploring your strengths in this club. And then you can join us in our annual workshop, which is in the next semester, in the first semester. So you can join us to enhance your skills. All right, thank you. That is all from me as the mechatronics representative. Thank you.
Thank you, Brother Naufal. Is there any questions? Right. No. I'll assume that's a no. Okay, moving on. Next, I'd like to invite the representative from Department Council of Electrical and Electronic Engineering to give a brief overview of the department.
Assalamualaikum warahmatullahi wabarakatuh. We share the screen. Yeah, Assalamualaikum warahmatullahi wabarakatuh. And hi, I'm Fatiha, the co-chairperson for Electrical and Computer Engineering Students Association. So today I will introduce to you about ECE Student Society and briefly talk about our majoring. So this is our chairperson, Sister Bakis Patricia from Computer Information Engineering, and me myself, the co-chairperson from Communication Engineering. And these are our secretary and assistant secretary, Sister Anis Sabrina and Sister Shaida Nabiha, both are from Computer Information Engineering. And these are our financial controller and assistant financial controller, Sister Izati from Communication Engineering and Sister Shazrin from Computer Information Engineering. Okay, for the new curriculum structure, it is applicable for students with matric number 202 and above. And for the overview of courses of our majoring, it is given a new name of Bachelor of Electrical and Electronics Engineering with Honours, and is in duration of 8 long semester with 1 short semester and with total credit hours of 138 hours. And the elective courses are offered based on specializations. So for our majoring, there are 4 specializations, which are Computer and Information Engineering, CIE, Communications Engineering, Microelectronics Engineering, and Power System Engineering. Okay, among the subjects taken for our majoring are the electric circuit, programming for engineers, electronic circuits, circuit analysis, data structure and programming, digital electronics, signals and system, electrical power generation and transmission, computer organization and microprocessors, communication systems, instrumentation, control and automation. So basically we're learning about electrical, electronics, programming, and also communication. And then, so the previous programs organized by ICESA on the past 10 years. So back then we have mass gathering, or we known that as the mentor-mentee program, where the lecturers gather with the students. So to introduce students to the lecturers and to get to know each other. And we also have tutor class where the senior student teach second year subjects to the junior students. And then we also have annual grand dinner, which is a team dinner where everyone gets to dress up and have fun. And it's also considered as a farewell for the seniors. And we also have family day where the students gather and play games to get to know each other and strengthen ukhuwah. However, for this program on the past 10 years, we cannot conduct it in the current tenure due to the pandemic COVID-19. So the programs organized by ICESA on the current tenure, which is this current semester, SEM 2, 2020 and 2021. We have 2 programs which are conducted online. MATLAB workshop. This workshop is instructed by Dr. Malik Arman, which is a lecturer in Kulliyyah of Engineering. This is a workshop that trains students to apply basic MATLAB on different applications. And we also have case study internship. This talk is given by Brother Irham and Sister Kamarina, where they are the alumni for ECE departments. It will help the student to prepare their resume and sharing tips on how to excel job interviews. So inshallah, in next semester, in SEM 1, 2021 to 2022, we will have 2 upcoming programs, which are the Python workshop, which aim to train students on the base of Python. And we will also have alumni talk, which is alumni sharing session with the students' onward experiences. So I think that's all from me. Thank you. So anything you can contact me or Sister Balkis. Before that, I will want to share to you with the study plan for electrical and electronics engineering. And Sister Iman. Okay, this is the study plan for Bachelor of Electrical and Electronics Engineering with Honours. So for semester 1, you will take these subjects: electric circuits, engineering mechanics, program for engineers, engineering mathematics 1, English for academic writing, and sustainable development issues, policies and practices. In semester 2, you will have electrical engineering lab 1, electronics, circuit analysis, data structures and programming, engineering mathematics 2, basic philosophy and Islamic worldview. And we also, in semester 3, you will have electrical engineering lab 2, electronic circuits, digital electronics, engineering electromagnetics and transmission line, differential equations, and so on. And then you will have in semester 4, you will have digital electronics labs, signals and system, computer organization and microprocessors, electrical power generation and transmission. In semester 5, you will have communication system, instrumentation, control and automation, power electronics and drive, and so on. And then in semester 6, you will have automation and instrumentation lab, digital signal processing, power system analysis, and so on. And then in your final year, you will have to choose the elective courses. So since we have for specialization, we have elective courses based on specialization, which is for CIE, Computer Information Engineering. You can choose technical elective, software engineering, data communication and computer networks, operating system, advanced computer lab. And for communication engineering, you can choose communication system design, RF design and microwave engineering, antenna and wave propagation, and advanced communication lab. And then for microelectronics engineering, you can choose whether to take semiconductor devices, advanced digital design, VLSI system design, and advanced electronics lab. For power system engineering, you can choose either power generation, high voltage engineering, electrical energy utilization and practice, and advanced electrical lab. So for the general elective courses, you have about 26 courses to take for elective courses during your final years. Okay, I think that's all from me. Thank you. Can pass back to Sister Iman.
Thank you, Sister Fatihah, for the brief overview. We'll move on. The next is aerospace and mechanical engineering. Please, Brother Shakir, please welcome.
Assalamualaikum. Right, good morning. Can I share my screen right now?
Yeah, sure. Go ahead.
All right. Can you see the slides?
Yep.
All right. Okay. So, Assalamualaikum warahmatullahi wabarakatuh. My name is Shakir Hilmi. I'm the chairperson of MEXA for this current tenure. So, MEXA is Mechanical Engineering Students Association under QE. So, for today's content, we have about 3 parts. The first part is introduction about MEXA. The second part is about the Department of Mechanical Engineering. And the last one, part 3, is about majoring in mechanical engineering. Okay, so first part, introduction about MEXA. So who is MEXA? Okay, so MEXA is a students association for mechanical engineering student of IIUM. And what do? We are involved in assisting mechanical engineering students in terms of exposure to the industries, welfare aids, studies, voicing out their needs, and anything related making mechanical engineering much fun, much interesting and fun. Okay, that is the most important part of being one of the MEXA committee, making the course and the majoring much fun and interesting throughout the tenure. So as you can see, this is the picture over here is the whole committee for this tenure of MEXA. All right. So moving on to the next part. Okay, still the first part, introduction about MEXA. So what are the programs that we have conducted this semester so far? Okay, for this semester, whereby this semester 2 of 2021. So in the early semester, we had already conducted an event called Kulliyyah of Engineering, whereby a bunch of students from any majoring, it is open to all mechanical engineering, all engineering students. They compete in a quiz of fundamental engineering knowledge. And then the next program that we have conducted this semester is MEXA Care Campaign, or in short, we usually call it as MCC. This one had just been done in the month of Ramadan. So this program is responsible to provide cash assistance, welfare aids, and also any coupons. So as you can see in the right poster over here, this is the continuation of MCC. These are one of the poster whereby this is the free food coupon available for all students. Okay, but there is more to come in the upcoming semester, such as Get Fit QE 5 kilometers 2021. This program has just been announced to be included in the Ingitex 21. So this program is about getting healthy together as the engineering students, engineering community, where you only have to upload any activities, running, swimming, walking, cycling, or 5 kilometers in Strava, and then you just have to upload it in Google Form, Google Form, and then you will get e-certificates, t-shirts, and such. And the next one is innovation contest. This is the contest where you are given a problem, and then you have to solve it as a team. And the last one is Aero Auto Weekend Talk. This is a program where you have a specific weekend where, for example, on Saturday, you will have a talk on aerospace, and then on Sunday, you have a talk on automotive talk. All right, moving on to the next part, the second part, Department of Mechanical Engineering. So these are the three important lecturers or personnel that you need to know when you enter degree in IIUM. So the first one is Prof. Meftah. He is the head of Department of Mechanical Engineering. And then the second one is Dr. Momen. You might have already met him previously early in this session. He's the academic advisor for aerospace majoring. And then the last one is Dr. Hilmi. He's the academic advisor for automotive or pure mechanical majoring. All right, the next one. Okay, the lecturers of mechanical government. Okay, the lecturers are divided into two. Aerospace lecturers, and the other one is automotive or pure mechanical lecturers. But along the way in your degree, you will actually incorporate it with both of these lecturers. Okay, so here's a little bit of fun facts. So the current dean of Kulliyyah of Engineering, the current dean is from the mechanical department, who is Associate Professor Dr. Sani Ihsan. All right. So the third part, the second part of this presentation, what major is about majoring in mechanical engineering. So what majoring is available under mechanical department? So there are two main majoring. The first one is aerospace engineering. The second one is pure mechanical engineering. Under pure mechanical engineering, you will have three more specialization, which are automotive, manufacturing, and energy. So these are the common questions that any first year students from CFS would ask because they don't want to get separated from their friends. So will we be learning different courses for different majors? The answer is yes and no. You will learn the same thing in the first and second year of your degree. Eventually, upon third year, you will start to learn courses that are more specific to your majoring. But you will sometimes be in the same class with other mechanical majorings. This is because, you know, we are under one roof, whereby which is the mechanical department. Okay, so the next one is about aerospace engineers or aerospace majoring. Okay, so what does an aerospace engineer do? Okay, so aerospace engineers usually involves in manufacturing, maintaining, designing, creating, evaluating anything related to aircraft, spacecraft, satellites, and missiles. So as you can see, these two pictures are only for aesthetics, but it explains the job of an aerospace engineer. So over here, the engineers are working on the turbine of an airplane, and then over here, the engineers are working on the body structure of the airplane. A little note over here. You can further inquire regarding the offered courses in all of these majorings by sending an email to STAT or one of the academic advisors for mechanical department. Okay, the next one is about pure mechanical engineers. Right, so what does a pure mechanical engineers do? Okay, this depends on the further majorings or specialization that you selected. So in the first case, if you selected automotive to be your area of specialization, so you become a mechanical automotive engineer. So what do? They will design, evaluate, manufacture, production of any form of land vehicles. Okay, so actually automotive engineer is always, people always limited it to only cars because automotive, but it is not that, because it is actually quite various and wide, because you can see over here, any form of land vehicles. So it is go as far as cars, buses, trains, motorcycles, and even bicycles. So yeah, it is quite a wide area of specialization. So the second one is mechanical manufacturing engineer. So mechanical manufacturing engineer usually works in a manufacture warehouse or anything related to it. So what do they do is manufacturing, evaluating, production related for any types of products that involves mechanical engineering. So maybe you will be handling the mechanical part of the production line, or even the mechanical part of the production system, you know, the drills or something like that, the robotics things. And then for the third part is mechanical engineer, mechanical energy engineer. So this is quite a new area of specialization, but it will have a very bright future, because as you can know, we are the majority of the world are depending on fossil fuels, which are not renewable. So we are in the era of racing against time to provide a good and efficient renewable energy. So this might be a good area of specialization for the future. So what do? They will design, develop, and test mechanical and thermal devices, and work on a variety of mechanical and energy components. So as you can see on the pictures over here, the top right one is where the automotive mechanical automotive engineer are working. This one is the mechanical manufacturing engineer, and the last one is the mechanical. Okay, this one I don't know if it explains the job, but let's assume that these two guys are the mechanical engineer, and then there's a wind turbine behind there. So we can assume that is renewable energy, so mechanical energy engineer. So again, little bit note, you can further inquire regarding the offered courses in all of these majorings by sending an email to STAT or one of the academic advisors for mechanical department. So I think the end, that's all from me. Thank you for listening and good luck. And my 2 cents of being in degree, I'm currently in my third year, is you have to enjoy it. Also, you have to work smart and don't stress yourself too much. That's all. Thank you.
Right. Thank you, Brother Shaki. Now I'd like to invite the representative from Department Council of Civil Engineering. That will be Brother Izzy. Please welcome.
Can you see my screen?
Wait, What are you sharing?
Oh, maybe I got some problem. Do you see my screen right now?
Oh, yeah. Okay.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Izzy bin Putra, current chairperson for Civil Engineering Students Associations, also known as CIVISA. So currently I'm here to promote our civil engineering department. So basically when you let's say that you choose to enroll as a civil engineering student, what are the most skeptical thoughts people will think about you? First is that they thought that you are the one who will do those hard labors. You can see that people will say it like this to you. Oh, you are civil engineering students. Did you build those house? So basically, all those hard labors are not done by us, but we are the one who design, monitor all those projects. All those hard works will be done by the what we call this in a site we call yellow hat workers. So because of this skeptical thinkings, I assume that most of the female students, they doesn't want to choose civil engineering because they thought that, oh, I have to do a lot of difficult works. So here's the things. So basically, when you are a civil engineer, you are not just related to buildings, but we have other specializations that we can pursue instead of structural and buildings and construction. So in our university, our department has provided 3 electives that you can choose when you are in the 4th year. So the first one is structural and construction engineering. The second one is water and environmental engineering. The third one, geotechnical and transportation engineering. So I want to address this matter to especially female students. You know, maybe you think that this is a male-dominated course, but it doesn't have to be. Right now, we are in the 21st century where we can say that everything that men can do, women can also do. So it doesn't have to be. If you doesn't like to do structural and construction, you can choose other specializations. Although you can see that our academic advisor also specialized in structural. We have a lot of female lecturers compared to the male lecturers. So that's why I want to say that you doesn't have to worry with all those what we call hard works. It doesn't matter unless if you like this civil engineering, you may pursue your degree in civil engineering. So basically, we as a CVSA, we provide some we organize some program for the students of civil engineering. So the most what I want to say is that when you learn, the best thing is that you have an experience of site visit. So yeah, we CVSA will try to our best to organize site visit so that it will benefit you. So here are some of our site visit. First of all, this is site visit at Batu Dam. So actually, this site visit is you can say that is almost compulsory when you are taking hydrology subject in your 2nd year. So you might have a chance, if there's no problem, you might have a chance to have site visit at Batu Dam. It is very good for you because you have to learn a lot of things. You have to learn about structural, you have to learn about water, you have to learn about environment, you have to learn about soil. So by having this kind of site visit, it can help you to get a little bit insight of what you are learning right now. So here's the first site visit, is our site visit at Batu Dam, and we have site visit at Terminal Bersepadu Gombak. So this site visit related to construction and structural engineering, and we have site visit at Super Galvanizing Malaysia Senaran Berhad, and we have site visit at National Hydraulic Research Institute Malaysia. So basically, this site visit is related to hydrology. You have to learn hydrology in your 2nd year, and also, if I'm not mistaken, 3rd year also. So you have to at least know a little bit, why did you have to learn water? Why did you have to learn soil? You are civil engineer. I'm going to build a building. So why must I learn about water? Why must I learn about soil? Because you have other specializations. And yeah, so as our CVSA current tenure, we have conducted few programs, and there are few upcoming programs. So the first one is Introduction to Civil Engineering. So this program, we focus on the 1st year students because we want to ensure that when you choose civil engineer, you know what you are going to do, you know what you want to you know what you are going to do, and you want to choose for your specialization. Because when you choose at the early stage, you can have a clear aim what you are going to be in your future. So another program that we are going to conduct a week from now is essential skills that hiring managers look for in engineers. This is what that we have planned. So next, our upcoming program is soft skills enhancement program, building structure competition. So the most what we call famous competition in civil engineering is tower bridge competition and tower crane competitions. But unfortunately for me myself, I never participate in those programs because of few circumstances. And lastly, we have webinar from ITIS. So ITIS is Integrated Transport Information System, which is related to our course also, which is transportation engineering. So we are trying our best, CIVESA, to provide a clear insight what you are doing right now. So I think that's all from me. If you have any interest in pursuing your career as civil engineering in UAE, don't forget to follow us, CIVESA_IIUM. You can ask us anything regarding our subject. Does it hard or not? You can ask us if you have any questions. I think that's all from me. Thank you.
Thank you, Reza, for your excellent introduction regarding CIVESA and the course. Following one excellent introduction will be another excellent introduction, inshallah, for this. It is my pleasure to invite the representative from Department Councils of Chemical Engineering. Sister Nisa, the floor is yours.
Okay, Assalamualaikum all. I will share my screen now. Can you guys see my screen?
Yep.
Okay. Okay. So Assalamualaikum warahmatullahi wabarakatuh. My name is Sayyidatun Nisa binti Syafo Azni, and I am currently in third year, second semester, and I'm the chairperson for Vesta Enginius. So as you guys are aware that the name of your department are going to be changed to chemical engineering, but as for now, the name for student society are still Vesta, which stands for Biochemical Biotechnology Engineering Students Association. So okay. So today I will like to okay. So as you guys have been exposed to the academic and career field by our AA just now. Now I would like to share to all of you how is it like to be Kulliyyah of Engineering BTE student from a student point of view, like what kind of society that you guys can join and what kind of activities and programs that offered. So firstly, I'd like to share these are the name of our main board for Vesta, and then in our society, we have few bureau, which is the first one, multimedia bureau. And then we have education bureau. Also, we have welfare and DNT. Also sports bureau. Okay, next, I would like to introduce to all of you. I would like to share to all of you previous activities from Vesta. So the first one is ROLPOP, which is a River of Life Project Outreach, which is a community outreach program under River of Life. You guys can, if you guys would like to know more about this, you guys would want to visit Instagram River of Life KL and Suka_ROPOP to know more about this. And so far, before this, almost every semester, Vesta sent a team to join this outreach program. Okay, the next one is educational trip, which also almost every semester before the pandemic starts. Every semester, Vesta has this educational trip, which give opportunity to visit company to widen knowledge and career prospects and real life application. And for previous semesters and previous years, the places that they went that Vesta has went are biology, Negeri Sembilan, and then Saim Darbi Klang, and also Yakult Seremban Factory. Okay, we also have a family day within Besta students and lecturers. And then every semester also we have a mentor-mentee session, which every lecturers are assigned to around 5 to 6 students, where we can contact to them directly as a mentor. And from the picture on the right hand side, that was way before pandemic, where we get to do a gatherings together with all the lecturers. And then the left one are obviously online session during this pandemic. Okay, we also have this is the program from our Welfare Bureau, which we provide a platform for students to talk about anything that they want to talk, and like spill their emotional thoughts on during our MO. Okay, we also have a children from our Sports Bureau. And then we also have intern talk, which as you guys would like to know that we are going to undergo our internship right after we finish third year. So right after we finish the internship, we usually do a session on Instagram Live, where we have two speakers or around 2 to 3 sessions for them to share their experience during their internship. Okay, we also this one is the latest activities that we just did, which is a tutoring program where we focus on the third credit hour subjects, where we assign a tutor for each subject, three credit hour subjects for second and third year subjects, where the tutor will provide a module which consists of quiz assignments and maybe past year's questions, and they will have a session with classmates around 2 to 3 days before midterm and also before final exam. Okay, so besides Besta, we also have Chemica, which is another club under Department of BTE. So what is Chemica? So Chemica stands for Chemical Electrica, and they have an annual competition held by Chemical Engineering Technical Division, IIUM, Institution of Engineers Malaysia. And each team will have to design a small-scale car prototype filled by chemical reaction. And this car has to carry a certain load during competition and must pass through fixed distance in order to get points to win competition. So these are how the prototype car looks like. So the achievement of IUM Chemical team was they were listed among top 20 winners in 2018 Malaysia Chemical competition in Terengganu, and also ranked 10th out of 64 teams in overall ranking of Chemical 2019 at UniKL Melaka. So if you guys would like to know more about BTE, you guys can follow our Instagram, Besta Clan. And we also have a group WhatsApp, Biochemical Community, which consists of lecturers and also alumni from this department. So that is all from me. Thank you.
Sister Nisa, maybe if you can show the slide for the WhatsApp group again.
Oh yeah, sure. Okay. Okay, here is it.
Right, then. Yeah, all right.
Okay.
Thank you. Okay, thank you, Sister Nisa. Next, I'd like to invite the representative from Department Council of Manufacturing and Material Engineering. Please welcome Sister Rashida.
Thank you, Sister Iman. I will share my slide first. All right, can you see my slide?
Not yet.
Not yet. Can you see it now?
Yeah.
All right, thank you. Okay, so Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning to everyone. My name is Wanashidah binti Wanzuri and I am the current chairperson of Manufacturing and Material Student Association, MESA. So let me just brief a little bit of what is manufacturing engineering and what is material engineering, because our academic advisors already briefed truly everything, basically everything about manufacturing and materials. So I'm just going to touch a little bit. So if you're hearing manufacturing engineering, the first thing what your thought must be, oh, we must work at the factory. There's no other place, right? So actually, there's a lot of, it's a lot more than that. You're not going to only work at the factory only. So in manufacturing engineering, it is consists of a common concept of other fields, such as mechanical, electrical, mechatronics, and others. So the main idea is to design and produce better products with some improvements of functions with lowering costs. So in manufacturing engineering, if you are here with us since the early in the morning, all the academic advisors mentioned about engineers manufacture this, manufacture that. So actually in manufacturing engineering itself, it's a core of engineering. Without manufacturing engineering, we cannot manufacture anything, right? So manufacturing engineering is one of the important course that we need to learn. So as manufacturing engineers, we are the problem solver, not the operator. We are not the one that need to deals with the machines and all that. We are the engineers, you know, the problem solver. So other than manufacturing engineers, we also can work in as a quality engineers, process engineers, manufacturing technician, and many more. So for materials engineering is actually the mother of engineering. So without the materials, what are we supposed to manufacture? So materials engineering engineers are the one that will provide other engineers the materials that they're going to use in their fields. So what they will make things that are stronger, cheaper, lighter, more functional, and more sustainable. Yes, they manipulate the materials and make sure the properties and the process is a better material. Yeah, that's the key of material. Then okay, so the properties of a material are intimately related to its structure at all levels, including which atoms are present, how the atoms are joined, and how groups of atoms are arranged throughout the material. So they learn about all the material structures to make it a better material. So other than material engineers, they also can be design engineers, research scientists, and metallurgists, and many more. Okay, so I will continue with our student association, which is Manufacturing Material Engineering Student Association, MESA, which leads by myself, Rashida as a chairperson, and these are our boards of 2020 and 2021. So these are some of our programs that we have managed to do throughout this semester, last semester and this semester. The first one is our car wash Memesa 1.0, which we actually did this in campus with we're following like strict SOP that we follow, and we managed to collect money funds to conduct a food distribution for Raya, which will be held inshallah later in next 2 weeks. We're going to distribute Raya food to all in manufacturing and material students that are stranded in campus right now. And we are also planning to do a Memesa Car Wash 2.0 in the next semester, inshallah. And we also have conducted the Aruf Week for second intake student. We just do it online or fully online. We also did academic sharing with freshies, which the speakers are our former president of MESA and the head of academic MESA. So this academic sharing, we did we explained all the study plan, which really helped the first year students. And then our current program, which is the webinar session, which is a collaboration with MTech, Advanced Manufacturing and Materials Research Unit. This webinar session is actually a weekly program combined with seminar class. In each classes, we invited people from our people from our industry. They're going to share their experience. What is it like to be an manufacturing engineers and all. So they share their experience, their thoughts, and their path along the way to be an engineer. So these are our future programs. We are planning to do site visit if this COVID already gone, inshallah. So a few site visit for manufacturing and material. And then we are going to do e-sport competition, maybe career talk, and also virtual run. So that's all from me. You can follow our Instagram at MMESAIIUM for further informations and to follow up with our upcoming programs. And also you can join our Telegram at MMESAIIUM also. So that's all from us. Thank you.
Thank you, Sister Rashida, for the presentation. And thank you so much to all the speakers for the wonderful brief of the Department Councils of KOE. I'm sure all of us have gained a lot from this speech. Talks upon talks, speeches upon speeches. Is everyone holding on all right? So straight away, we'll move on to our last slot, which is industrial sharing. Without further ado, I'd like to invite Brother Muhammad Rizwan Muhammad Hamid to deliver his talk today. Please welcome. Brother Muhammad Rizwan.
Hello, Assalamualaikum. Can you hear me? Hello?
Now we can hear you.
Alhamdulillah. Okay, so where did I lose you guys? So was it from the beginning, is it?
Yes, actually.
Okay, Bismillahirrahmanirrahim. Okay, thank you for Miss Iman, our MC for the day. Okay, my name is Rizwan Hamid. Okay, so let me start with Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya wa mursalin wa ala alihi wa sahbihi ajma'in. Okay, thank you very much for having me today. And thank you to all 45 participants that are joining our session today. Okay. So first of all, my name is Rizwan Hamid. I am the pioneer batch for materials engineering, graduated in year 2004. Okay, I am also currently the president of our engineering alumni. The engineering alumni name is COEX, as in KOE, Kulliyyah for Engineering, X students, and the X is representing X students. Okay, so I am required to give a talk regarding the industries. So let me just share about my working experience, since I graduated in 2004. Okay, so after my graduation, what I did was actually, instead of looking for a job, I wanted to do my own business at the time. So because during my study years, I also did some part-time teaching as a tuition teacher, physics, chemistry, and maths. Yeah, we are engineering students, so those are normally the subjects that we are good at. So I wanted to open up a tuition center. So sometime in December 2004, I was approached by my supervisor when I did my internship. So he was looking for an engineer. So he initially asked me what to do, what I was doing. So I was happily explaining to him that I wanted to set up a tuition center, teaching students and everything. So after that, he went quiet for maybe like 5 seconds, and then he asked me whether I want to go to Sudan or not. So right away after that, I accepted his offer. And in February 2005, I was posted to Sudan as an engineer, as a mechanic. Actually, at the time, I was attached to the procurement department as a mechanical engineer for mechanical project engineer for a pipeline project. It's a 1,800 kilometer pipeline project. And we were building the pipelines for the client name is Petroda. So it's an oil and gas company. It's an oil and gas operation company. So the oil is from South Sudan all the way to Port Sudan, which is next to the Red Sea. So that was my first assignment from 2005 until end of 2006. So my background is as a material engineer, but as a material engineer is basically a subset of mechanical. Okay, so some of the subjects that mechanical engineering students study, we also study, especially in relation to mechanics of material and everything. So at that time, I was exposed to mechanical principles and mechanical engineering knowledge actually at the time. So after 2 years in Sudan, I came back. Okay, of course, the duration is the package is we work for 3 months, 8 weeks actually, and then we come back and have a 2-week R&R rest. Then we continue our work for another 8 weeks at site. So at that time, it was in the middle of the desert in Khartoum. I have to go sometimes all the way up to Port Sudan, and then sometimes all the way down to South Sudan in Juba actually at the time. So it was quite interesting, and so it was my first job working overseas. It was my first job, and my first job involves me working overseas already. Okay, and then I came back to Malaysia. We were working on another project in Jakarta, in Indonesia at the time. The head office in Jakarta. We were building a gas booster station, gas compression station, to increase the flow of gas from Aceh. It's a long pipeline from Aceh all the way to South Sumatra for transportation to Java Island. Okay, so I worked for that project. with for maybe from 2007 all the way until 2008, and concurrently I was also working for another project in Malacca to build the largest hydrocarbon collection tank, crude oil collection tank in, at the time, Southeast Asia. It's a 76-meter diameter tank. It's a very huge tank in Petronas Penapisan Malacca at the time. So all these 3 projects were mainly on mechanical. I was more involved on mechanical and project management. Okay, so during these first 3 years, since I was working at site, so I was involved in a lot of hands-on. Let's say when involves pipeline projects, and time I even had to go down and support the pipe fitters, the welders to do their work, supervise their work. And of course, as engineers, we have to solve the problem. Whatever issues arising from the site, we have to figure out using our engineering principles that we have learned and on how to solve the problems. Okay, and also we were required to do reporting and of course communication with our HQ in Malaysia at the time. I was for these all 3 projects, I was with Malaysian Mining Corporation Oil and Gas, MMC Oil and Gas actually. Okay, nowadays MMC Oil and Gas no longer focus on EPCC projects. It's called EPCC, Engineering, Procurement, Construction and Commissioning projects. They just focus more on engineering projects as per se. Okay, and in 2008, okay, 2008, sometime in May, I resigned from MMC and I joined another company named SBM Offshore. SBM Offshore is it's a French company. At that time, the company is already around 75 years old. So it's very old company, a very well established company. And it's a very huge company because it operates floating production storage offloading facilities. Okay, I'm going to give you some of a lot of my talk will involve oil and gas activity because this is where I'm from. I'm in the oil and gas industry. Okay, so I believe some of you guys would also like to know about oil and gas industries. But in oil and gas industries, it covers a lot of disciplines as well. We have mechanical, we have electrical power systems, we have instrumentation for communication system, we have civil and structural as well, because all of the facilities were built using steel structures. So there's a lot of civil and structural engineering involved. And of course, everything involves chemical processes. So practically almost every majoring in UIA Gombak, once you guys go to Gombak, you can, regardless of whatever majoring that you guys join, there is always a possibility to join the oil and gas industry. Okay, so related to FPSO, FPSO ni basically is a ship, okay? It's a tanker ship where you have production facilities where you process the hydrocarbon coming out from the ground until the end product is crude oil, export crude, for it to be transferred whether back to land for further refining or through another shuttle tanker to bring it to another location. Okay, so I was working with SBM Offshore from 2008 until 2014. Okay, so around 6 years. At that time, I was assigned to the main engineering office is in Malaysia. We have 4 engineering offices around the world, and Malaysia is our 4th engineering office. So at that time, I was assigned as a materials engineer. Okay, so as a material engineer, what I did was I was required, okay, as our previous speaker, Dr. Warashidah, as our previous speaker mentioned. Okay, a materials engineer is basically the first engineer in any projects. Okay, what we are required to do is when a project requirement arrives from the client, the project engineer is required to select the most suitable material fit for purpose. Okay, if you want to build a structure that can last 200 years, so the type of material that you want to select must be able to withstand whatever environmental and process requirement, so that the system, the entire system, can sustain 200 years of operation. Okay, so it has to be fit for purpose. So so if there are more advanced requirements, more advanced project requirements, so the material needs to be developed using manufacturing methods, advanced manufacturing methods, so that it can meet the requirement of the projects or requirement of the equipment that needs to be developed. Okay, so I was a materials engineer doing material selections for all the oil and gas facilities designed by my company for 2 years, and the rest actually 1.5 years, and then the remaining 4.5 years I was in the piping department. So I guess some of my photos has been shared earlier by the material academic advisor. Okay, so that's basically me on where I do my work. Okay, so after 4 years, okay, sorry, throughout these 6 years with SBM, I was assigned to Angola, okay, to work in Angola, and we have an FPSO, we have a ship over there, so I was assigned there to do as a piping engineer, actually, to assess the life of the piping system. Okay, to assess the life of the piping system, because that facility was actually aging, so we need to do some major refurbishment work on that facility. So a job as an engineer doesn't just involve design. You have to be able to perform whatever required task from the beginning of the work, beginning of the project, all the way to the end life of the facilities. Okay, so and should you require to extend the life of the facilities, you will still require to you still have to play your role as an engineer. Okay, so that's one point during my engagement in Angola, and I was also involved. I was also assigned to Jakarta, okay, as an interface manager at the time, because when you do projects, sometimes you cannot. Okay, wait. I'll handle the questions later. Okay, you cannot be confined to only one scope of work. Okay, you have to be able to understand. Let's say you are a mechanical engineer or electrical engineer. You also have to understand the work and relation of your job with respect to other disciplines as well, because you guys are working in the company, and your company normally produce or provide services related to a specific product, and that product normally doesn't just involve a single discipline. Let's say, as an automotive engineer, the car itself has the structure itself, which involves structural analysis that is best done by the civil engineers, and then even mechanical engineers, and you finite element analysis, the same principles apply. And then you have materials engineer involving the type of material, the type of coating, the type of painting system, and everything. And then you also have instrument engineers, which is communication engineers for control system, the instrumentation and the interfaces within the car. And of course, you have manufacturing engineers, because in Proton and in Produa, most of the work involved is basically on manufacturing processes of all the parts of the car, and not the design of the car entirely. Okay, so a lot of disciplines are involved. So as an engineer, you need to be very sure that you need to be aware that all your work needs to be in relation to other disciplines as well. So back to my job as an interface engineer, when I was in Jakarta, I had to coordinate. Okay, I have to coordinate all disciplines related to my company, from my company, with our business partners. Because when you build structures or when you build facilities in most cases, you cannot build the entire facility. You might have to hire another subcontractor or another business partner to build your facility, to complete the entire facility that you want to build. And of course, you have vendors, sub-vendors, contractors, partners, and everything. So you need to coordinate with them as well to complete your final product. Okay, so fast forward to 2014, I resigned from SPM. Then I joined another company in Dubai, actually, in Dubai, in UAE, for my next assignment in Iraq. So I was in Iraq throughout 2015. So yes, it's a war-torn country. I agree to that, but of course the people there is very, very nice. So I was involved in the state. My job is in the state of Misan. The name of the oil field is Halfaya. So my job was as a lead piping engineer at the time to supervise all contractors being assigned by PetroChina. Okay, being assigned by PetroChina to develop the field. And then in 2016, I joined a company. It's a UK-based company. We have around 40,000. We have around 22,000 staffs globally. The name of the company is Petrofac, and I've been a lead piping engineer with Petrofac, the subject matter expert for mechanical piping, and from 2016 until today. Okay, all right. So let me just address the question first. I would like to ask Brother Ridwan, in this pandemic era, would you advise us, the material student, to work or pursue our studies, and why? Thank you in advance. Okay, good question from Sister Raina. Okay, so I've read the question. So allow me to share my screen, because that is exactly what I'm going to present actually. Okay, the future of work after COVID-19. So before I proceed, I want to can all, because this is Zoom, right? Can I see a show of hands from the members to see whether all of you guys are actually hearing me or not? Hello. Okay, quite a number. Only 3-4 je yang hit raise hand. The rest, can you guys hear me actually? I want to make sure that you guys are actually paying attention. Okay lah. Boleh lah Okay, let me share my screen again. Let me know if you want me to speak in Bahasa. I have no problem, since all of you guys are actually Malaysians. Okay, so let me continue. Okay, the future of work after COVID-19 is, you can see over here, COVID-19 is basically a serious pandemic actually that is happening currently. A lot of us actually, even some of our alumni members has lost our job, and some of us have already been made redundant. Some of us had to endure or suffer salary cuts. Some of us has had to sell their houses. So the situation is really, really difficult actually for everyone. Okay, but for my younger brothers and sisters, current students, okay, what I can share is that with respect to the pandemic, somehow the industrial revolution, the IR 4.0, the industry 4.0 revolution has somehow gained some benefit with respect to this pandemic. Okay, why? Because originally in 2011, okay, the term IR 4.0, the 9 pillars for industry 4.0 was actually coined by a German researcher. So initially, okay, when people were farmers at the time, the first revolution was the steam engine. No, sorry, was the spindle actually. Was the spindle. So people started to mass produce products, and we start seeing a shift of people working in the fields. Okay, at the time working in the fields, they can be, maybe they are working farming on their own farm, or farming on other people's farm, on land lots. Okay, so then they start going out, leaving their farms or their employers' farms, and they started to actually work in factories. Okay, doing manual work. Okay, but at the time we start seeing machines, small machines, simple machines, basically steam engines, steam machines. And at that time, give me a second. Okay, let me just share this first. All right, can see this, right? Okay, so first, in start seeing the mechanization, water power, and steam power actually being developed for mass industry, and then in the early 20th century, 19 something, okay, start seeing mass production and assembly line, electricity. Okay, so for the first industrial revolution, actually, the main keystone was actually the development of steam engine, James Watt steam engine. I'm sure all of you were aware of this, about James Watt. So development of steam engine actually changes the landscape of society movement from traditional farmers to factory workers. And then when Thomas Ford, when Ford started their T line engine, when Westingate versus Edison electricity race to produce either DC current or AC current to the entire states of America. That was in 1902 or 1908, if I'm not mistaken. So that was the time when the second industrial revolution started, because at the time machines were no longer run using steam. Machines can now be utilized using electricity. Okay, and then in 1970s, started the development of transistor. Okay, and development of transistor actually shapes the changes, shape the landscape from shape the landscape from very crude electric power machines to machines that can be operated using small computers, or machines that can be requested or can be instructed to conduct 2 or 3 steps rather than just a single step machine. Okay, and then in 2011 is the advent of cyber physical systems, which is the advent of industry 4.0. Okay, so back to COVID. Industry 4.0 has seen a tremendous growth, where people are required to stay home. Okay, so a lot of works are to be done at home. So a lot of demand has increased from traditional physical work. Okay, where I had to do so when I started work, I had to jump into the trench, I had to go to the site and work everything. And comparing to now, I manage my work. I manage the entire facilities that I have, 3 wellhead platforms, 1 wellhead support structure, and 1 FPSO with my company. I manage it from my PC here at my home. So whatever issues at site, we have people working at site, they take photos, they send it to me, I provide the solution. So that's how it is after 16 years. Previously, it was different. Every time there's an issue, the engineer will have to jump, go all the way, regardless of wherever it is, or across the world, he has to do it, and then go at site, see the problem with his own eyes, and only then provide the solution. Now, can just video call and solve the problem there and then. Okay, so over here you can see kind of work that is required and increase. Okay, first, this is basically a general, doesn't focus on engineering entirely, but then there's a lot of industries, okay, like outdoor production and maintenance is obviously involves engineers. Transportation of goods, of course, to maintain the fleet, still need engineers. Classroom training for engineering education, computer-based office work, and then indoor production. So from here you can see low physical proximity and high physical proximity. So from here, the type of remote work will be more and more required. So type of engineering also, actually the more type of engineering work that requires remote work will also shift. Okay, so let's say manufacturing engineers. From those days, we expect the engineer to be at site. These days, since we are going to expect machines to do the work, the engineer can manage the job remotely from home, or maybe at worst, maybe 1 or 2 times, 1 or 2 days per week, attendance to the factory. Okay, you don't really have to be there right away, because with you have machines, you have cameras, you have control systems that can log data, and logging software. They can provide all the data, and from there you just have to analyze the data and provide your solution. Okay, and digitization, you can see 2 to 5 times growth in e-commerce as a surge in digital platforms, because more and more products are being sold online. More and more products are being sold online, and obviously more and more services are also required to be sold online. Yeah, and then automation, uptick in use of robotic processes, automation, and AI. Okay, so I received a comment actually from one of the participants that it is that some of the students, some of the engineering matriculation students are actually contemplating to apa nama transfer, to convert or to transfer from engineering to ICT. Okay, so well, you don't really have to do that actually, because if you go to ICT, it's not that you're going to become a programmer. Okay, and when you program, when there's nothing to be programmed, if there's no machine, there's no equipment, and there will be nothing for you to program. So in the end, it will be just an overpool of programmers, and there will be no engineers to do the work. So it doesn't work that way. And if there's too many ICT members, you will end up like India, only becoming a service center with no product to offer. So a troubleshoot company. So I hope it doesn't work that way lah. Okay. So you have all the industries, aviation industry. They say that aviation industry is dropping, but then the cargo, because you see transportation of goods in my previous slide, transportation of goods has increased. A lot of items have since, because you can sell item online now, so you can see more and more purchase being made from all over the world. So the transportation has increased. So there's no reason why they shouldn't be. So there's no reason why aerospace industries doesn't grow, because the more items that needs to be shipped all over the world, and some of the items will require urgent shipment. So you'll see an increase in terms of cargo flights. So it doesn't, to say that aviation industry is heavily impacted is not entirely true. Cargo pilots are having the time of their life. They don't have any issues with their work. Okay, and then automotive industries, people still use vehicles to go to work, or people use vehicles for their daily commute. There's no issue. Of course, the sales may drop for a while, but then it will eventually normalize. And once people accept the fact that they need to minimize their exposure outside, they will still drive, but they will choose where they want to go. So it's not really an issue. Same goes for other industries. When there's a demand, you see more increase in sales. You'll see more increase in manufacturing activities. Doesn't change. Materials in development. When you have more equipments being produced, you'll see more maintenance. And materials engineers are also involved in maintenance of equipments. Actually, when it comes to RBI, reliability-based inspections and everything. MCI, material and corrosion. Actually, a lot of materials being developed, so obviously there'll be risk and corrosion. So that's where material engineers will play a role. A lot of buildings will still be required. People stay indoor a lot, so we'll still see population growth. So you'll still see requirements to have houses. So there's no issue in that. Okay. Even in communication, a lot of people are using internet. More and more people are using internet. So communication industry will still grow. There's no issue at all. Okay, so it's not that once you have industry 4.0, there will be no other industries, meaning other traditional engineering industry will drop. It's just how the industry is being developed, or just how the industry is being managed will be changed. Okay, I hope it's very clear to all of you. If you have any question, feel free to ask me in the chat function. Okay, I have another question. Throughout your journey, which position you love the most and satisfied the most with the salary being offered to you? Okay, so when the word salary is being mentioned here, I have to pull back a bit lah. Actually, I expected this kind of question. Okay, so it's like this lah. Let's say you work in a company, okay, and the company can only produce, let's say you have 3 people in the company, and the company makes around 10,000 ringgit per month. Okay, so you have 3 people in the company, it makes 10,000 ringgit per month. Okay, you know that you have to deduct your costs. You know you have to deduct your overhead, meaning the rental, electricity, water bills, and everything. And then you'll have maybe around, maybe I don't know, 6,000 left. So you have a boss, you have someone that you know much senior than you, and you being the youngest one. So do you expect the salary to be distributed evenly for all 3? Definitely not, right? Because if you are in the boss position, you wouldn't be accepting to evenly distribute the salary. So it depends on the requirement is, okay, basically when you join, whatever principles that you study during your studies here, okay, will be applied for your work. Okay, but then again, it will be applied in your working area based on the requirement of the company. So in the end, it is how much you can contribute to the revenue of the company. Right, so if you join and there are still many things that you do not know about your product service, about your product, the company product or the company services, and you cannot even generate sales to the company. So how do you expect yourself to demand for a certain salary? Okay, so it has to be both ways. So once you join, you show your self-worth, how you can contribute to the increase in sales to your company, and from there on, you have a basis to justify what salary you require. Okay, that is just a suggestion, just a point of thought, basically. All right. So back to the question, which position I love the most? Well, I love all of it, basically, to be honest. I love all of it. There's no issue with me having to drag my feet to work. Okay, that is the most important thing. When you start dragging your feet to work, then you know you need to change your place. So I've been a materials engineer, I loved it. Being a piping engineer, I've loved it. Being a mechanical project engineer, I've loved it. And now I'm managing projects as a engineering coordinator. Also, I love it. There's no issue. I think all jobs are being placed related to my, of course, I've been an interface manager and I've loved it as well in Jakarta. Of course, it's an aspect package. They give me house, they give me vehicle, they give me extra salary for me to stay in Jakarta. So even my kids went to international school, so it's quite okay lah. Right? Okay. So, well, I love all of it. I cannot say most satisfied with the salary being. Of course, if you cannot find the satisfaction, you have to be fair with yourself. You receive a salary, you think that is too low, you have to reflect back. Did I contribute enough to justify any higher salary? Okay, and that is the first question before you start considering of jumping to another company, because in the end, it will never end. It will never end. Companies companies do require people, but if all the candidates start demanding for unreasonable salary, they will go back to the current employees and decide, okay, then we will just focus on optimizing our team rather than having to hire new people. And in the end, nobody gets new jobs. So this it has to be a win-win situation. And that's what's currently happening in my company. We have too many fresh graduates demanding for unreasonable salaries. Fresh graduates now asking for like 6,000-7,000 ringgit, when even people with 3 years experience, some of them not even reaching that salary. And so in the end, we decide, okay, we don't hire them anymore. We just focus on our people, empower our people. So we don't want that to happen to you guys as well. Okay, another question. How and when we should start to find our internship, especially for third year students? Okay, okay, how about internship? About internship. First of all, during your second year, you can start during second year. First year is for you to in Gombak is for you to actually acclimatize, for you to normalize the workload being given by the lecturers. Okay, it's quite sometimes it will be quite overwhelming. Every time there's a class, you'll be given assignments, and all assignments due date deadline is on Friday. So the reason why there are so many assignments being given per week, okay, workload is I would say is very demanding. The workload as an engineering student is very demanding. So why does lecturer give so much workload? Is because that is basically how basically what you will have to do when you work. Engineers are normally put under pressure and being given a lot of work. Why? To justify the salary. Otherwise, if you're given a work, easy work, you can do one work per week, very easy, and then you spend most of the time doing something else. Then how do you justify your work? Okay, so that is the training that the lecturer is giving to you. So normally that's what we do during the first year, and then during the second year, because we normally do our internship at the end of the third year, between the third year and fourth year. Okay, so you can start doing research for your internship during your second year first semester or second year second semester. You have to identify and be sure of what kind of industry that you want to join. Okay, so first year normally you don't have any idea what kind of majoring that you want to do. Second year you join your majorings, and then second year second sem you start to you might have to attend this subject we call seminar, where you start seeing people from the industry coming in and telling some stories about what they do in their work. Okay, so at the whole idea is for you to have an exposure on how people in the industry conduct their work or conduct their activities. Okay, so the type of work also being done by the industries. Okay, so that is also the right time for you to start researching. If you want to do communication, what are the main players for communication engineering? What kind of companies hire communication engineering? So you have your entire second year, second semester, third year, first semester to do this. Okay, and then during the third year, second semester is normally where you start issuing out internship letters internship application letters to companies. Okay, so the university internship coordinator will guide you, will provide you the relevant documents, the cover letters and everything, but it will be up to you to do your own resume, to do your own cover letter, and then issue it on your own to these companies. So at that time, maybe it's good for you to review some of the YouTube videos on how to find a job, how to actually ace in interviews, because it's pretty much the same, basically. Okay, I hope it answers the question. Okay, any question, any other questions? Because I think my slot is until 12:50, so I have around another 6 minutes. Any questions from my brothers and sisters? If you want to switch on your mic and ask the question also, no problem. Some of the members are actually texting me in WhatsApp because they have my number. Okay, all right, Aman. Okay, so no questions, Sister Iman. Oh, Sister Iman. Hello.
Yes.
Why?
Okay, so sound that we don't have any other questions. So what do I do now?
I think Brother can maybe give us a conclusion for this slide.
Okay, conclusion. All right. So, well, it's an industrial. Okay, so basically, I'm required to give industrial sharing, which I've given the industrial sharing already. I hope it's beneficial for everyone. And okay, so yes, things are changing because of the pandemic. Things are changing because of industrial revolution. Okay, I want to maybe share an analogy, okay, to all those joining this. Okay, on the importance of having very good grades for your, regardless lah, your CFS matriculation ke, for your degree ke apa ke. Okay, it doesn't really matter. But then this is the I want to emphasize the importance. Okay, so this, I'm going to share an analogy. Okay, let's say you have a workshop. You have a workshop which specializes on repairing BMWs. Okay, the BMW car, luxury car. Okay, so you have two new workers. Okay, worker A and worker B. Okay, so one of them, okay, you don't really care about their CGPA. You don't really care. They might be graduates from degree ke, graduates from IKM ke, with sijil kemahiran, or they can be graduates from college kemahiran, and you don't really care. And because your company makes a lot of money, you can afford to pay these two young technicians or two young mechanics salary at the same time for 3 months before you start asking them to actually do their work. So what you do, because your car is such a specialized car, BMW car, you give manuals to technician A, to mechanic A, and to mechanic B. You give books to them. Okay, the BMW manual. Okay, so you tell them, all right, I give you 14 weeks. Oh, sorry, I give you 12 weeks. 3 months, and I give you 12 weeks. Okay, so at the end of the 12 weeks, I'll give you 2 cars of identical damages or problems. If one of the candidates can fix more than the other candidate, I'll hire the better candidate. Okay, and of course, throughout the 12 weeks, you will allow the candidates to go around and see and maybe try to fix other things along the way if they want to. Okay, and maybe sometimes you'll give them small quizzes to see whether how much they have read the manual. Okay, so after 12 weeks, you see one mechanic able to fix maybe around 80% of the car damage, and another mechanic can only fix and only repair 50% of the car damage. Which one would you hire? Obviously, the mechanic that can fix at least 80% of the car, right? Okay, so and then why do we give 3 months? Is because because that's as much as long the time that you think it would be reasonable for any technician or any mechanic to understand exactly what is inside the books, inside the manual. Okay, so same goes with our education. Okay, some of us maybe might have been thinking that it doesn't really matter what pointer you are. In the end, what matters is how you do your job. Unfortunately, the companies doesn't know that. The companies doesn't know that you are capable to do the job, and they don't have that much money to give you 3 months trial. Pay your salary for free. After 3 months, see whether you can do actually what an engineer job is. Okay, so the only way they can rely to is to see your grades, because the university has structured their semester and their testing system, and for every 14 weeks or 12 weeks, there will be one semester, and that is how long you're given your textbook. By the end of the semester, how many can actually memorize or understand or solve problems related to what is given in the textbook? More than 80%, you'll get an A. If only 50%, you'll get a C. Right. So That's the only way a company can assess before they hire you in. I'm sure you understand, right? That is the only way. So that's why they refer back to CGPA. And of course, CGPA, you have so many subjects together because there are so many manuals and standards and codes that such engineer needs to understand before they can solve any specific problem related to the work. So that's why you have so many subjects, so many engineering principles that you need to understand. And of course, it's staggered per semester. Why? Because you want to maintain consistency throughout the year. Yeah, that's why you have carry marks and everything. Because we don't want people who start the study in the early of the year, play along, do something else in the end of the year, slow themselves and score during the final exam. We don't work like that in companies. We want consistency in performance in companies. Okay, so I hope that simple analogy is sufficient to motivate my younger brothers and sisters, okay, to focus on your education in the future, be it during matriculation. I mean, I think you guys have it until July, right? And then once you join Gombak campus, please focus on your academics. Make sure you graduate with as high as possible, and of course strategize on where you want to go and which industry you want to join after you graduate. Okay, all right. And of course, alumni, we have alumni members. We are quite we have started our alumni association in 2019. We have been conducting quite a number of programs, career talks and sharing sessions with the alumni members. Currently with COVID, so most of the events are being done online. Okay, let me share with you the type of session. I'm not sure you guys can see it here. Let me share my screen. Okay, so we have career talks. And then sharing, yeah, we do have seminar. So this is me being one of the seminar speaker. And then we have, okay, this is integrated design projects for, okay, this is me doing seminar. And recently, most recently, we do our career talk online. So we had 658 YouTube views. So we have around 3,000 alumni, we have around 3,000 students, right? So 600 people view it in YouTube, and 312 registered the form. Zoom attendees, at one time we had 171 Zoom attendees, some of them coming in, some of them coming out somewhere along the way. So we have some of our seniors, some of our speakers. This is the faces of some of our alumni members contributing back to our younger brothers and sisters, or in your case, to your seniors in Gombak, to just to share with them what is to be expected once you join your degree. Once you finish your degree. Okay, so I think that's all from me. All right. Well, if there are any other questions, just let me know, or I'll hand over back to the MC. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Sorry, just now I got kicked out when you called me.
Okay.
Yeah. Thank you so much for the very insightful speech. It gave us a peek of what the world outside may offer. Now that we finish all our slots, we thank you. We thank all the participants, everyone who came here, who joined us today for this event. Before leaving, there is the feedback form that will be posted in the chat box. So you might want to help us out, fill that. That is all. That is all. Thank you so much, everyone. We end our event with Tasbih Kafara and Surah Al-Asr.
Sinar insan ala fi husnil ladzina amanu wa amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Okay, thank you all. Okay, Assalamualaikum. See you guys again, insyaAllah. All the best for your final. I want to ask, kalau ada yang nak jawab lah. You guys sampai bulan 7 ni je kan?
Bulan 7 apa?
Matrik. Sampai sebelum masuk Gombak.
Oh. Persilakan siapa-siapa nak jawab. In the chat box maybe.
Yes.
Oh, nak tangkap gambar? Okay. Dah tangkap gambar ke belum? Si Raudah cakap nak tangkap gambar.
Sekejap kita tunggu 40 sekejap.
Tunggu yang lain-lain online Okay. So, siapa jawab jadi soalan pasal korang sampai bulan berapa ni?
Betul sampai bulan 7.
Sampai bulan 7. Lepas tu masuk Gombak bila? Bulan 9?
Tak sure. Kena tengok balik kalender.
Rasa kalender buka bulan 9 ni kan?
Sebab tengok dia punya course tu kata bulan 10.
Oh, ada extension sikit. Okay. Alright. Tak apa, nanti lambat sikit. Dia okey tu benda lah lalang. Ni dah habis kan? Dah habis session Lalang lah. Janganlah rasa ketinggalan kalau kawan-kawan budak you lain masuk awal sikit. Berapa bulan je pun. Nanti dia orang grade lebih kurang sama juga. Macam zaman kami dulu. Kami matrik 2 tahun tau. Sebab bahasa Arab ni masalah. Matrik 2 tahun, degree 4 tahun. So time tu zaman Bamat. Nama saya Rizwan, orang panggil Abang Mat lah. Lecturer pun panggil Abang Mat. Yang lagi tua daripada saya pun panggil saya Abang Mat. Saya pun tak faham. Tapi tak apalah, itulah namanya kan. Satu planet UIA panggil. Okay. So kisahnya, waktu Abang Mat dulu belajar, kita orang dah lah matrik 2 tahun. Budak-budak zaman kita orang matrik setahun. Lepas tu dia orang terus masuk degree. Engineering kat setengah-setengah UC macam UPM apa semua, dia orang buat 3 tahun. Kita masih 4 tahun. So ada yang dah grad 2 tahun lebih awal daripada batch kita orang. So waktu tu memang kita orang frust lah, sedown sangat kan. Kawan-kawan dah start kerja, dah start melaram tunjuk ada kereta lah, ada kereta lah, motor dekat motor kita pun ada kan. Melaram tunjuk kereta lah, dah start cakap pergi jalan sana, jalan sini. Waktu tu memang kita rasa ketinggalan sangat lah. So waktu tu mula-mula ya betul, kita rasa ketinggalan. Tapi bila kita masuk kerja, kita notice since kita mungkin slightly lebih berusia lebih atas senior setahun 2 tahun daripada rakan-rakan sebaya, kita jadi jauh lebih matang dan kita lebih cepat diberi peluang sebab dia batch yang masuk, yang geng-geng ni masuk awal, budak you lain pun mungkin setua 2 lebih kurang sebaya dia orang, jadi benda tu macam lebih kurang sebaya je perangai dia orang. Tapi bila kita masuk, kita jadi macam lagi senior sikit, lagi senior in terms of umur lah, jadi kita jadi lagi matang. Lepas tu di UIA kita fokus banyak pada bahasa Inggeris. Memang lecturer bahasa Inggeris dah lah, lecturernya pun lecturer luar overseas kan, jadi banyak lah bahasa yang macam jadi macam susahnya nak faham. Jadi kita, secara nak tak nak kita akan improve kita punya English comprehension. Dan dalam industri memang kita banyak speaking. Hatta government agency pun in the end banyak speaking daripada cakap bahasa Melayu. Cuma time meeting je lah cakap bahasa Melayu betul. Kan? Kalau tidak memang most of the time memang bahasa Inggeris. Even in terms of kerja, in terms of meeting, memang that's how the business language lah orang cakap, business language. So kita akan jadi lebih cepat perform sebabkan faktor peringkat lebih senior tu, lebih matang, kita lebih perform, kita lebih berdaya saing, kita lebih lapar. Sebab kita rasa kita ketinggalan. Jadi kita lapar nak mengejar apa yang kita rasa